$100 cheaper there. But ever since then, they've not been cheaper in Japan. I don't know. It was just the way the currency had shifted just before my trip there 2 or 3 years ago. Everything was a lot cheaper there. Ever since, it's been about the same price or more money.
I noticed a lot of camera equipment is generally cheaper in the Asian countries. I don't know what it is. Every time I go to Taiwan, it's like, oh, I really want to buy this lens. It's like $200 cheaper here.
Yep.
Good reason to go there.
Oh yeah, we're supposed to. There's might be something in Taiwan in November. Was it?
November, is it? Yeah. I don't know the dates yet, but it's November.
Just crop that shot a little bit better. Yep. Shoutouts. The chat room says that my guest looks like Evil Riker.
Great, thanks.
That was a compliment, by the way.
It is, yeah.
I need to reverse my chair so I can step over
There you
it.
go.
That would be good.
All right. All right, are we ready to go then?
Yep.
I think so. Is my background noise, microphone all good?
Yep. Good.
Okay, good.
Just gonna
Nothing
adjust
to
the
hear.
size of this window a little bit so I can see the chat room while we're going. Get the quiet keyboard in case I need to type because my main keyboard is too noisy. Okay.
Yeah. I like that one.
Somebody in the chat room was asking about, said if I was wearing a red shirt, you'd worry, but
What's-
so
this
my
week's
shirt is
t-shirt?
gold, by the way. But anyway. Okay. You ready to do the? Sorry, did you pick a title, Wendell?
The one was fine. The level 1 host or whatever.
Level 1 text, website and podcast.
Yeah, that's fine.
Okay. Benedict just needs to know so he can introduce you. All set there, Benedict?
So it's, I guess so. So it's Tech Wendell basically,
For
and
what?
then as a name.
Oh
we
yeah,
have-
just Wendell is fine.
Okay.
Or Wendell from level 1 or Wendell from level 1 text or whatever. Doesn't matter.
Just some kind of introduction. Yeah.
Okay, ready, Benedict?
Sure.
And recording.
We're joined this week by Wendell of the Level 1 Tech hosts and website and podcast. Can we do that again? It's the week. First day of the week. It's
Okay.
yeah. Sorry.
The chat room says there's only
Good.
one Wendell, so it's fine.
Yeah.
And recording.
We're joined this week by Wendell of the Level 1 Tech's website and podcast. So you probably have heard about the interview that he did with Alan Jude the other day or the other week. And so we thought we might as well return the favor. And this is our interview coming right now. So, since you haven't been on the show yet, tell us a little bit about yourself and how you got started with the whole Unix, Linux, BSD podcasting thing.
Well, thanks for having me. Those are kind of separate stories, I guess. The podcasting thing is something I've fell into recently. I never thought I would. It's like I always thought of it as like, well, I mean, why would I do that? It's not really. It's kind of vapid. Do I really want to do that on the internet? It doesn't really make sense. But then I kind of fell into it, and it's more fun than I expected, and I got to meet a lot of really interesting, smart people and sort of ride their coattails and ask them questions, and so I see value in that. But how I got started in this, how I got started with Linux, I think, was around 95 or 96. So I've been using Linux a while, but I was in high school at the time, and the high school had a token ring network for most of their computers, but they had just gotten a T1 line for the internet. And so there was only like 6 computers in the school that could get on the internet because the equipment provided by the ISP was Ethernet. And they were like, how are we ever going to network our stuff with token ring? And, the state Board of Education, whatever, was like, well, we'll have to buy a piece of equipment that's like $10,000 in order to do it. And another student and I had been dicking around, I think, with like Linux 1.2, 1.1, 1.2, 1.3, something like that in that era. And it had IP masquerading, I think is what it was called at the time. And so we were banging on, 486s, like 48625s or 386. It might have been 38633s, but 4625, something like that, trying to get IP masquerading working. And we got it working. So we could provide we could provide internet service for all the token ring computers via Ethernet with a computer that had both the token ring and an Ethernet adapter in it. And it was like, gosh, this Linux thing is a lot more functional than Windows. This is kind of neat.
Yeah.
Yep.
So back then, this wasn't the distribution. It was basically just the kernel and some userland utilities, or?
I think it was Slackware. I think Slackware had just been put together, and because there was a T1, it was like, okay, we can download it and put it together. And so like one of the Windows computers, we would download it and put it on a whole bunch of floppies and then sort of install it through floppies. I wouldn't swear that it was Slackware, but I think it was a very early version of Slackware.
Yeah. So I guess getting to the other part of the question, how did you come up with the idea for this level 1 text thing and getting into podcasting?
Well, I really just sort of fell into it. I knew somebody that did it, and it was like, hey, there's this thing that we can do, and it might be really good. And you're sort of on the technology side already. I've been doing. There's an XKCD comic where the first couple panels are like, they gave me an impossible problem to solve and I solved it, and then the panel kind of forks, and one side is like academia, and so the last panel is like, oh my god, people are going to be writing their PhD thesis on this. We're going to need a whole bunch of students to look at this for their dissertation. And then the other panel where it forks is that's like in academia, and then it's like solving the impossible problem in business, and that panel is oh, that's great. Can you also get my Outlook to stop unjamming or to stop jamming up or whatever? And so I went the business route instead of the academic route. And so I've been doing this stuff for many, many years. I just never did it on the internet. But then it's like, okay, well, maybe there are some interesting stories here. Maybe I can meet some interesting people. So some of the people that I've worked with in my career, we just sort of put it together, and it's like, here's some interesting projects. Here's some stuff that we're doing. And we try to make it sort of accessible. It's very much lower level, but a lot of the time with a lot of the technical stuff, people that are getting started or students that are enthusiasts or whatever, they don't really know where to start. It's like, I kind of like computers, I kind of like technology, but what more is there? What more can be done? And it's like, well, you can do 3D printing, you can do programming, you can take over the universe with artificial intelligence now because Google's released TensorFlow, and that's sort of the new hotness. And you can do all this really interesting stuff with technology, but a lot of the time people don't necessarily know how to start or how to find a community to just sort of be able to do that. And so it's not just that we have computer scientists in the community, it's also like makers and doers and sort of the fusion where all that stuff kind of comes together. And that's really been a lot of the stuff that I've worked on in my career, is things that are sort of gluing that stuff together, where you're not really inventing a novel solution for like the traveling salesperson problem. You're just, using existing off-the-shelf stuff, glue it together. A lot of open source factors in there, using open source technology to solve the problems. And so it sort of becomes, I guess, a design pattern for what different kinds of people would want to study, depending on what their personality is and what their interests are.
Mm.
Yeah, and
Yeah,
you
it's
know, some of
also.
it is a lot of research gets done nowadays, but especially the types of conferences where they present the research aren't usually attended by the type of people who would then apply that research. Uh, and it's often a problem that we come up with all this interesting novel research, but nobody ever gets around to trying to build something out of it. Or they
Yeah.
do, but it's 20 or 30 years later. You know, like virtualization and the whole idea of containers and capabilities and all the security frameworks for computers. Like, yeah, most of these papers were written in the 70s and then rewritten again in the 90s or early 2000s, and now we're finally doing something with them.
Yes, that is exactly. It's all about accessibility. It's like, look, this is not rocket surgery. We can totally do this.
Yeah,
Yeah,
it's a,
and add some missing bits there. Yeah.
yeah. The episode we did 1 or 2 weeks ago, we actually talked a little bit about that for because of the volume of research papers and so on that get written. There's actually a need for another job in the middle of somebody who basically distills a bunch of papers on a topic into a shorter, more easier to digest bit, just because if you want to do new research, you first have to, unless you want to repeat previous mistakes, you kind of want to learn all the previous research. So you have to do all this work to climb up this mountain before you can actually start working on top of it. And if we build a staircase to help you get up there, then we'll get more new research faster and maybe actually start applying it faster. But, you know, when the ideas are first generated, they're very rough and ill-defined, and we need oftentimes the type of person that does the polishing isn't the same type of person who comes up with the idea originally. And so we need all the different
Yes.
people, and we need to make this stuff accessible to more people, so that, because maybe they're the ones that can do the distillation, or the one that's going to take that distillation and actually build something useful out of it.
I would say it's also true that the people that want to do something new don't understand that they need to do a lot of practice on the old stuff first in order to be able to do the new stuff. Because practicing the old stuff, sometimes it's really hard to get at the kernel of interesting information in the old stuff, because it is so inaccessible, because there is no staircase, because this reason, that reason, or the other reason, but it's platform limited, or you need the researcher that put this together, it's like this specific version of GCC or this specific whatever, and it's like, well, I don't have time to resolve these kinds of dependency problems or whatever. And it just comes down to documentation and all the stuff that nobody wants to do.
Yeah. So, as a good tie into the next question is, so from your point of view, how did the Linux world change from your perspective in the last couple of years?
I don't know that I'm really like. Basically, I'm an internet bozo. Like, I mean, I have a computer science background and I've done a lot of programming. I wrote a Linux kernel module around kernel 2.0.36. It was just a device driver for a touch screen. And so it's not really like anything magical or anything crazy, but I think that Linux, even like going back to my earliest memories, Linux has the inertia of like a 3-mile long cargo train, and it's moving at an unbelievable speed, and it's accelerating. And so it doesn't turn on a dime. It doesn't decelerate. It doesn't really do anything,
Right.
but it is accelerating. And so the number of developers and the number of people that are putting work into it and that kind of thing is increasing. But the direction in development is not always like super focused. There are some counterpoints to that. Like, I was really excited to see Canonical the other day say that they're dropping Unity to go for GNOME. I think GNOME or KDE are really good desktop environments, and there are more esoteric, sort of desktop environments that are it's not to say that other desktop environments are bad. I just think that in terms of like Linux accessibility, GNOME or KDE is probably it. Unity always needed a little bit more than it had,
Yeah, well, I think
in my opinion.
all of them need a bit more than they have to actually get there. And if we divide the effort up in a bunch of different places, it's even longer before we get there.
Yeah, exactly. And so the inertia helps in that situation, but it would be that much better if the train weren't trying to go in 4 different directions and we could just, sort of barrel through this. I mean, to look at it another way, look at Android. I mean, Android, Google, has spent, bathtubs and bathtubs of cash on Android. Sure, that's fine.
Mhm.
But look at how far they've come with Android with almost, I don't want to say laser focused, but a somewhat focused ability to sort of co-opt Linux and turn that into their platform. If we can have somebody that would do that a little bit more altruistically with an open source desktop environment, whether that's Linux or something else, I think that would be a very successful project, although maybe not commercially successful in the way that Android has been commercially successful for Google.
Right.
Mm.
There's a lot of ways in which Android's been a failure, especially with the fragmentation and so on. But at the same time, it's undeniable that it's on how many billion devices? So
Yeah, exactly. Well, and it's even as fragmented as it is, a lot of the basics of the usability is still there. I mean, I think the fragmentation problem could have been solved if Google had the clout today that they did when they started. Like if they were as large and
Yeah.
if they could just strong arm because a lot of the changes in Android I think have been more toward being able to subvert the types of things that are making it fragmented.
yeah, like I think part of it was Google maybe not having the clout, but the other part was Google originally didn't want to be involved with the phone part as much.
Yeah.
And then you got each manufacturer being like, well, we're going to put our glue on this. And a lot of that, I think, even if just the companies that were customizing Android had learned from open source, especially like anybody who builds an appliance on open source quickly learns the lesson that you follow the head of upstream while you're developing your product and you don't get behind, because once you get behind, that forklift upgrade is a doozy. Lots of FreeBSD based vendors have learned that one, like Juniper and Isilon and NetApp and so on. They learned very quickly that, hey, if we just keep up with head, because if we base the product we're starting today on the current release, that'll be 3 years old when our product comes out, and that will be bad.
Yeah, you don't automatically get the features for that. I think also the whole Oracle Java thing probably slowed them down a little bit there too.
Right. Yeah. That's also a contributor.
Yeah. So, do you think that the starting point for people getting into Unix and Linux and BSD and so on has gotten easier, or do you think there's still the first step is still kind of high?
You sent me that question, and I've changed my answer mentally 3 or 4 times since then, and it's all just
It's
again,
so much easier than it was,
internet.
but it's still so much harder than it should be.
It's a little bit of that. It's true, but it's weird in unexpected ways. And so, like, I did a pass through video last year, which has been really popular. There's a lot of people on our forum that have they're running. They still want they really like Linux, and they don't trust Windows. And so the pragmatic solution is you just run Windows in a container and you can play your games, but you got to pass through, a physical piece of hardware, graphics card or whatever, in order to play your games under Linux. And so I did a guide on that last year, and it's been really popular, surprising, and it actually was very straightforward to do that, like on Arch Linux, which is not. I definitely would not say that is a newbie friendly distribution. And I went into it not expecting to like Arch Linux. But the more that I used Arch, the more that I really liked it, and I like the things that it does, but the way that it manages packages, and I use that term somewhat loosely because it's a spectrum of how managed exactly those packages are, and sometimes not at all. Sometimes it's just, well, here's a link to a repository, good luck. And so I find myself sort of liking that approach, and that approach has been surprisingly robust compared to like mainstream distro, even like mainstream distro upgrades, like going from Fedora like 23 to 24 to 25 to 26. The 25 to 26 is in beta. The beta right now is still a little rough for Fedora 26 in terms of like the upgrade packages and sort of managing the system and that sort of thing. Debian is always a pretty smooth upgrade, but it's also tends to run behind even if you're running, like testing. It's still just, it's not really like super up to date and super standardized. And so you have the other distros like Mint. Mint is really popular as a like an intro distro on our forum. People just pick up Mint and sort of run with it, and it's okay, but you really, you really get into situations sometimes with it where you're trying to manage a package, you're trying to do an upgrade, and it doesn't necessarily work out the way that you expect. And there's little weird things too, like Open Broadcaster is really cool, but Open Broadcaster in some of these distros has a memory leak bug that's well known, and just for whatever reason, the package that's available in the repository, the memory leak bug has not been fixed, and it's been like 6 or 8 months or 10 months, or it's maybe a leak caused by a certain library on the system, and maybe that's not what has been updated. But this kind of problem basically didn't exist on Arch because it was just plugged into the source repository. So it's crazy because it's like Arch is actually more user friendly as long as you know all this other stuff.
Yeah, it's oftentimes it's because the packages are pinned on the other ones. You end up spending more time jumping through the hoops of trying to deal with these older things and the fact that all the stuff doesn't update in step with each other, than actually just getting work done. But if you get to the rolling release, if something goes wrong, then you have all these other problems too. And
Yeah.
it's
You can't. It's like rolling release or pinned packages. They have their upsides and downsides, but it's like, even in the quote unquote commercial distros, in the enterprise, like to answer the question from the standpoint of like the enterprise, it has gotten dead easy.
Right.
Companies like Microsoft and Oracle have got to be sweating bullets because, OpenSUSE, Red Hat, Enterprise Linux, you can take a junior administrator that's got maybe a year of experience and turn them into a productive admin in no time at all. And it's not Linux on the desktop. It's not whatever. But in terms of like a server operating system and being able to set up the kinds of things that you might need for a work group, it has gotten way easier the last 5 years.
Yeah. But in those cases, if it's great for doing the things it was meant to do, but if you want to do anything slightly different, then you have the problem of, well, it's CentOS 6 or RHEL 6, so the packages are 4 years old.
Well, that's how it is in the enterprise anyway.
Yeah, exactly.
Some enterprises.
But it's kind of why I like the position that FreeBSD's put itself in, where you have a stable operating system part that's every 6 months to a year or something like that, you get an update. But your packages, you have the choice of the daily rolling release of source and binary packages, or the quarterly, where you get 4-month kind of pinned with security updates so that you don't have as much churn, but everything's still fresh, right?
Well, I think the managing of updates and stuff, it seems like it's much easier to roll back to a previous point in time. So like if you are, if you're doing the rolling and release thing, it seems like it's pretty easy on FreeBSD at least to say, okay, that went horribly wrong. Let's just reset to where we were before I attempted to do this.
Right. Well, that's mostly a ZFS feature rather than a FreeBSD feature.
Well, there you go. It's tricky. I haven't really attempted it. I kind of sort of attempted it once, but I kind of sort of attempted to see if I could maybe set up a Linux system that way, and I was not really super successful doing that.
Yeah, a bunch of the
but
glue
I have a
is
feeling
missing
it
still.
Yeah. It's
Especially the bootloader parts where you can select which boot environment to go back to.
yeah, yep, yeah. I thought it was a worthy experiment though.
Mm-hmm.
Yeah, sure.
Yeah, but one of the students applying for my GSOC project actually has a third laptop that's FreeBSD and Arch on the same ZFS pool. And they
That's pretty
cohabitate.
cool. Just different data sets or
Yeah,
whatever.
different data sets, and then I don't know what he does in the bootloader. I imagine EFI, and then something like refind and pick which OS he wants and boot it.
Neat.
Yeah.
Yeah.
Yeah, theoretically that should work.
Yeah, theoretically, exactly.
Okay, so do you go to any conferences or meetups? Which ones would you recommend?
I'm going to PenguinCon at the end of the month, and so I'm really looking forward to that. PenguinCon is small enough to be intimate, but large enough to have interesting topics. And so Last year, I went to a really good talk with Jason Mars, who's in charge of a project called Lucida. It used to be called Sirius, but then Apple was upset that it was called Sirius because it's an open source
Too
personal.
close to Siri.
Yeah, but that's the joke. It's Siri for us, so Siri. But now it's called Lucida, so at least that's the unofficial version. And that is sort of quintessentially what we were talking about earlier in the program with the whole, like we need a staircase, we need to kind of sort of figure it out. Because if you look at Lucida and you look at the stuff that the University of Michigan is doing with it, it's really super interesting. And they've got AI. It's not like when you're building a personal assistant, it's not just like you install it. There's natural language query, but you've got different kinds of natural language queries that you might want to do, and then you need something like Wikipedia converted into a format that those things can search. And so it's really this huge ball of programs put together a certain way, and then you've got an assistant that maybe can do something useful. And the talk was interesting because it was there were a lot of people in the room who were like, what are the practical applications of this? Is this something we can download now, or are you just talking about it? It's like, no, here's all the componentry, here's all the stuff. I mean, here's a pre-trained neural net from Google that does pretty decent speech recognition. Here's where you can get the training material for this so that you can build your own. And here's where you can get a version of Wikipedia that is formatted in such a way that the neural net can search through it more easily, because it's, you can ask a question like, how tall is the Eiffel Tower? And it's formatted in a way that you can take the natural language query and the voice recognition, pipe that into another thing, and get the answer. And so Penguicon, I think, is really cool for those kinds of talks, and those kinds of things.
Yeah. Do you have
Isn't that
the
also a
dates for that handy?
conference where
I know
Yeah.
Michael Lucas will be there.
Mike-
I think he's giving
Right,
3
yeah.
different talks.
Yeah, they make you do 3 things if you want in free, and it's just like, Jesus, that's a lot of work.
Yeah. Well, he does
Oh,
enough
well,
different
you're
things with
used to
his fiction writing, nonfiction writing, and BSD stuff.
April 28th through 30th, 2017 in Southfield, Michigan.
So that's coming up shortly.
Yep. Other things that I go to, I like to go to Computex. It's in Taiwan. It's a little bit more mainstream, but Computex is also really interesting because there's sort of like this sideshow off Computex. And so like main Computex is like, oh, Intel, AMD, what are we doing? Oh my God, it's crazy. And then there's like this other building that is like a business to business thing. And so you can go meet companies that are doing things interesting. And so I was able to sort of hook up with a company there that it was the first company that had a conversion chip that could do DisplayPort 1.2 to HDMI 2.0 with Chroma 422, which was kind of a big deal on AMD cards because AMD cards didn't have HDMI 2.0 out. And so you had to get an adapter, but for like a year, it was basically impossible to find that kind of adapter stateside. And it's because there was only one company making a chip to do it. And so it's like, oh, I can go to Computex and find somebody that has this thing so I can get it, and it's fine.
Yeah, that's cool.
Cool. How did you first discover ZFS?
I think it went something like this. So I got to university, and at the university they had a VMS system, and so that was fun. And so I'd gotten pretty proficient with Linux by the time I went to university, and it was like, okay, this is gonna be fine. No, VMS, my God. But it had one really interesting thing. It had file versioning, and so you could create a file and then save it, and then save another file over top of that file, and it would just append the version number to the end of the file. And it's like, wow, this is really cool. And I think at that time I was running like XFS. I want to say that like XFS wasn't in the Linux kernel. You had to get a patch for it. But I'd saved up, and I'd sort of done the e-waste thing. Like I'd worked for a kind of a large company, and they had sort of fed my hardware addiction by giving me some of their cast-off stuff. And so I'd managed to get my hands on it like a 9 gig, 10,000 RPM hard drive, and it was like, this is amazing, 10,000 RPM and a desktop drive. This is just crazy. And I was running XFS on that, which required kernel patches, and then so I was really into XFS and all the stuff that it did. And XFS was so fast, it was crazy. And then on the VMS system, it's like, oh, I could get used to this file versioning thing, because to my knowledge, there wasn't any real way to do something equivalent. And then a few years later, I think I was messing around with like I don't know, I think it might have been FreeNAS. I'm not sure. Something happened in there, and it was like, oh my God, ZFS does this. This is crazy. I need this. but it was probably like 4 or 5 years later. But I'd never really found anything that really scratched the itch. And then it was like, oh my God, ZFS does this thing that I really like, the only useful thing that the VMS does. I really need this. And then this is pretty much the end of it. And ZFS has like all of my archive, long-term storage, important stuff has all been sort of ZFS since then.
Yeah, it's like I remember when I first heard about it, and I looked and it was like, oh, it's a Solaris thing. And I don't care. And then a little bit later, it's like, oh, it's on FreeBSD now, and it's been around a little while, and it's like, so we're building this new storage server, and it's gonna have like 8 hard drives, and that would be an awfully big UFS RAID array, and that would take a while to check, and it's like, oh, this ZFS thing seems cool, but I didn't 100% trust it. So that first ZFS server has a UFS mirror of 2 drives for the OS, and then the 8 drive Z-pool. And it's still like that, although I regret that now. Because I'd really like the operating system and the home directories to be in the pool instead of not. But yeah, I'm not entirely sure how I learned about ZFS and got into it either, but I know that as soon as I did, I stopped caring about every other file system.
Yeah, that's pretty much. I remember being annoyed with some of the setup stuff for ZFS. I remember being annoyed with like having to set some of the particulars, and it's like, why do I have to think about this? This is a file system. And then I sort of was reading the man pages and going through the documentation, and it's like, okay, well, there's no real way to not have to deal with this. So it makes sense now. I understand. But it wasn't until like actually bothering to go through and understand why that it was the way that it was that I had an appreciation for all of the stuff that it made me do. Whereas, on XFS, it's like there's like 3 variables that I might want to mess with, and then it's like, okay, everything's good. It's great, good to go.
Yeah, well, ZFS is relatively straightforward now, right? It's like you have the zpool create command, which is the equivalent of like newfs or whatever they call it on Linux, but it is a little bit more complicated. But compared to setting up,
yeah, it's much better than it was.
Compared to setting up Geom RAID 5 or something on FreeBSD, it's a few less steps.
Or the Vino stuff before that.
Oh, Vino. Yeah, I don't even want to.
Atlas. Oh.
Yeah.
Looking back, it's always, oh my God, we did all that stuff, and now it's just a couple of commands.
Nowadays, it's like, well, I have this system with 200 terabytes of storage in it. How would I even do that without FreeBSD or without ZFS? It would be, I would guess I would have made a whole bunch of separate RAID volumes. I don't think I would have trusted a hardware RAID card to do all of those at once, and they're spread across cards, so that wouldn't have worked. And oh my.
No, I've definitely, well, in doing like the I work through school, and so I got to do all kinds of fun stuff with working through school. And working through school, I was definitely there when very large commercial arrays failed. And so I was there, I was definitely there to witness and or experience, companies that, not any kind of choice that I made, but it was, it's like, okay, our 12 drive, whatever, the controller crapped the bed. And now it's like, do we get the exact same controller? Do we stock the same controller as a thing? The new controller won't import the old controller's volumes because that's only a relatively recent feature. Like being able to do that is kind of a new thing. And in early 2000s, it's like, oh, you don't have version 3 of that RAID card? Sorry, you're boned.
Yeah, and it's like, oh, we haven't sold the version of the card you have for a couple of years now. Good luck finding one.
On eBay.
Should have got that support contract.
Whereas,
all the research data is gone.
ZFS took that a step further and be like, oh, you need to move a pool between your Spark machine and your your AMD 64 machine. We can do that. Byte swapping's no problem.
Was there a free version of Solaris before Open Solaris? Because I want to say that maybe I downloaded that and messed around with it, and then I think I did import that pool on another system later. I'm not sure. That's been so long ago.
Yeah.
So there definitely was a Open Solaris version when Sun was still around. But
right.
I'm not sure about the name.
Going back further than that, I don't know.
Yeah, it was kind of those were the Wild West days. And at university it was like, oh yeah, we got some Sun machines over here and some of this, and it's like, why don't you take this back to your dorm room? Nobody's using this. And it's like, well, okay, whatever.
No problem here. So, what would you say is your favorite feature of ZFS?
Well,
Any
I mean, can there be just one? I mean, I don't know. I like
difficult to
how
choose?
I like how my favorite feature is that it is as robust as it is. Uh, I've pulled some information out of a ZFS pool that should have basically been at a point where it was like all the data is gone, it's completely written off, and the code, like I had to turn off some safeties in the source code and do some other really horrible things, but I got all the data back for somebody that I knew, and it really wasn't bad. Like, it was not a terrible experience. Like, I don't, I'm not a particularly gifted or experienced programmer, and I was able to look through the code, understand what it was doing, understand the failure mode, understand why it wasn't mounting the pool, understanding why I couldn't walk the tree, and then I was able to use the debug tools, stuff like that, to pull that out. I've looked at the code for like ext2, and it's not really like, there's some stuff in there. It's
It's been around for a while.
I can't imagine
That
doing
doesn't
the
make it
same.
necessarily better.
Yeah, I can't imagine doing the same sort of process to be able to sort of, walk the tree and kind of figure it out with ext2. I've never had to. Maybe I would change my mind after I did, but I was really impressed with how robust and organized ZFS was, sort of during that recovery episode. And that was basically multiple drive hardware failure, and the pool was also completely full, like no free space at all, and it was still a recoverable situation.
Yeah.
Yeah.
I've not read any other source code that has that many ASCII art diagrams.
Yeah, yeah.
Well,
Like,
it
this is
helps.
fairly,
Yeah.
yeah, this is easy to understand. Well, not easy, but
Yes.
it's a pretty straightforward
Easy,
to
yeah.
understand. Yeah.
There was a talk Matt Aarons gave at the ZFS user conference a couple of weeks ago, and he was asked a bit about technical debt in ZFS. And he's like, well, in general, all the major technical decisions we made have stood up well in the last 15 years. There's a few bits of the code where we would like to improve it so that it's easier to understand and easier to work with and modify. But, as far as they're aware, there are no major, gnarly bits of code that are holding ZFS together with spit and gum kind of thing.
I've got a Fedora box that has all of our video on it, and I've got the snapshot system tied to a script that is doing like 2 or 3 snapshots a day, and it keeps like a week's worth of snapshots, and then it'll keep less snapshots from the preceding week, and then it'll keep like the last 6 or 7 snapshots for the last 6 or 7 weeks, like 1 or 2 snapshots when you're talking 4 or more weeks ago.
Mhm.
And that feature is really nice to not really have to worry about it or think about it, or it's like, oh, this thing that was deleted like 2 weeks ago, we didn't notice, and it's like, okay, let me just go click and get it back, and it's super easy to deal with those kinds of situations, and so that's really nice.
Yeah, I use that except for snapshotting on 15-minute intervals to replicate data like the TrueOS package repository to many servers. So we have very frequent snapshots for that bit, and then we only keep the very frequent for like 6 hours, and then we drop off to every 6 hours, and then eventually one every third day after it's a month old or whatever.
I do have a success story too. Recently, there's a program that I support that deals. I don't really know how to explain it. It's an overly complicated interface for dealing with a bunch of text files, and the text files range in size from like 4 kilobytes to like 160 kilobytes.
Oh.
And I migrated about 800 or 900 gigabytes. There's 8 million files in total. And I migrated it from XFS, from a system that had been running for about 8 years, 7 or 8 years, to a mirror, a ZFS mirror, and to walk through all 8 million files now. And it's on NVMe, so it went from spinning Rust to NVME.
Mhm.
But with the built-in compression, it is a style. It takes 8 minutes to walk through all of the files across NVMe now, and it's basically is a CPU bound. It's almost a CPU bound function. I mean, the NVMe is basically running it at almost probably like 70-80%, and the application can keep up, and it's really pretty amazing. It is astonishing how much faster, because I'd initially tried just like, okay, let's just keep everything the same and move it over, because it uses some of the extended attributes that XFS has, but it was actually really easy for me to translate the program from using the XFS extended attributes into something that would be compatible with ZFS, for marking the files and saying this file has gone through this process and that kind of thing.
Mm-hmm.
But yeah, like 8 minutes, and it's mind blowing that it's that fast, and
the compression ratio is probably also a big plus.
Yeah. The compression ratio is like 2.35 to 1 or something, and I didn't even tune that. I think that's still like the default compression, which I guess is LZ compression.
Yeah, LZ4, yeah. That's usually what you want because it's the fastest. But yeah, that, and then now that we have the keeping stuff in the ARC compressed, including metadata, I imagine with that feature that'll get even faster because you'll be able to store that much more of the metadata for your 800 million files in RAM. And you know what's the only thing that's faster than an NVMe is RAM.
Well, that system's only got 128 gigs of RAM, so
yeah, but if you're getting 2-to-1 compression, the metadata is not very big.
True, that's true. It's nice. It really is nice how fast and how reliable it is. Plus, I'm also not really worried about bit rot anymore because I might need a text file from 5 years ago, and I don't really want to make sure that it's there if I need it.
Yeah, the checksums. I don't know how we live without them. So speaking of that, kind of, what upcoming ZFS feature are you most looking forward to?
I think probably the middle of the road compression that you were talking about on the thing that you did with me last week. I think that will probably be good, especially on modern hardware, because modern CPUs are so insanely fast that seems like a good balance, especially when you're dealing with like a mostly archival, not really it's archival, but you still are using the data set continuously. That seems like the perfect use case for that, because gzip's
too slow, and Z standard, the compression rate is good enough that, short of if you have a mirror of NVMEs or something, it's not going to be the bottleneck for writing. And then for reading, it's so much faster that, again, it's going to outpace your disks, so you're not going to end up CPU bound on the decompression, and so there's not a major performance impact unless all your CPU is already busy doing something else, in which case you need more CPU. So yeah, I'm thinking that will make a big difference in, with the cost of things like SSDs and NVMEs, bumping that compression ratio from 2.3 to 1 to 3.3 to 1 can make a big difference for you.
Indeed.
Yes.
Plus, again, it can end up increasing the throughput because you're reading less data, so it takes less time.
Compressed sends will probably also be nice, but the workarounds for that really aren't terrible.
Yeah, you'll save a lot of CPU time, although usually all you're after is saving network time because it's a lot slower than your CPU, right? So yeah, that'll be nice to have as well.
Intel's already sold me more cores than I need. It'll be fine.
Well, yeah, the bigger problem is that usually whatever you're sending it over the network isn't using enough of the cores.
Yeah. Because the network card doesn't split it up and do the whole message signal and interrupts thing. Yeah.
So what feature would you like to see come to ZFS that isn't being worked on already?
Oh, see, this is, I don't know. I don't know what, I don't really know what my options are. Well, no, I mean, but I can do that with snapshots.
Yeah, with the snapshots.
So
it's difficult to think of something. And then when there's something new coming up, it's like, oh, of course.
Well, so the one that the chat room brought up was HammerFS has this feature called like lazy reclaim. So it's kind of like a snapshot, but different. It's when you overwrite a file or whatever, because it's always doing copy on write, it just doesn't free the blocks you just released right away. Right? So you actually keep the old versions of files for a number of minutes until its cleanup operation happens and it frees up those blocks to regain your free space. But basically, when you overwrite a file in place, the old version of the file still exists in this like magic snapshot. It's a virtual snapshot or something. So there's
I guess as long as you have free space,
Yes.
you can reach arbitrarily far back in time, as long as you haven't needed the space for something
right,
else.
and then there's an operation you crontab or whatever that cleans up the space, maybe once a day or whatever. And as long as your pool's not full, then you can get something like that. And something like that might be interesting. Although, snapshots are low enough cost, you can pretty much just take them very frequently and it'll be okay.
Yeah. It might be. Are there any this might have been covered in your book, because I think that this was kind of hinted around in some of like the performance tuning and the performance troubleshooting sections, but I haven't had time to like try it, and I'm sort of a learn by doer. And and that is there enough performance metrics or performance logging or whatever that if you create a data set, and like if let's say that you accidentally created a MySQL data set and you've got the wrong record size, that you could look at metrics later and be like, oh, the metrics for this are I created this data set incorrectly because it's asking for a lot of very small writes, but my record size is larger than it needs to be.
So
yeah.
dtrace could tell you
On
that
Solaris
probably.
and FreeBSD, you could just use dtrace to look at the size of the writes going to the pool, and it would basically create a histogram of those, and you would see they're all on the 16K mark, and your record size isn't, and you'd be like, oh, whoops. But some more stuff like that, I think, would be interesting. Just even just somehow logging when it does a lot of the read, modify, write cycle, like the write amplification. It's like some kind of counter of just how often that's happening, and if it's too much, then do something about it.
The
There was-
ZFS stats, maybe?
Well,
This-
I'm imagining something that runs more like over time automatically, that I'm not necessarily going to do dtrace immediately. Like I could see it as like, okay, dtrace is fine when I'm like troubleshooting an issue, but it might be more about how the users actually end up using the data set over time. And it's like, oh, I didn't realize that they were using it this way, or maybe I should just, add that to something that I check weekly or monthly. What made me think of it is there was a recent problem with Microsoft SQL Server. They issued an update that caught I was troubleshooting an issue where there was like severe performance degradation just out of the blue, and it's like, this doesn't make any sense. And it came down to an update from Microsoft that was aimed at improving performance on disks that had a 4K sector size, but the disks in the particular system I was troubleshooting only had a 512 byte sector size, and whatever that the software misdetected that it had 4K sectors when it did not, and so all of a sudden it's like the performance tanked, and it's like there was some option that had to be set somewhere, but figuring that out was near impossible. But I could see that you maybe would have a data set that over time you're dealing with, not in the MySQL case because that's MySQL is doing that on purpose, but I could see that you maybe have a data set that you use over time, and it's like, oh, this would actually be better if I changed the record size to this because of the usage pattern.
Yeah. Well, part of the point of dtrace is that you could leave it running all the time. I suppose if you did that with like a low enough sample rate, you could just, looking at a fraction of all the writes on to this data set, what is the block size we're seeing, and if it's not right, then maybe we should figure out, which program is writing the wrong size blocks and what should we do about it, maybe. But that's an interesting something someone could build. Although having something a little more built into ZFS might be interesting there. I'd love to see more stats and stuff in ZFS, or even just a native way to do like quality of service type things, like say this data set can only do this many IOPS, or this many megabytes per second or whatever. So FreeBSD's resource control system can do that. It's just not. It's a per file system or per process. I forget. You can't quite do it just at the dataset level like you would like to.
That's interesting. That might be. I didn't realize. Well, I mean, I'd forgotten that dtrace you could run at a really low sample rate, because every time I've dealt with it, it's like, oh, let's run it full bore, and it's like, oh, the system slowed down a bit.
Yeah. Okay. So tell us a little bit about that big storage server you built that kind of cobbled together out of bits. I think the audience will be interested in that one.
Give us stats.
It's made from garbage. it literally
where
is.
everything starts.
Yeah, I mean, it's like, okay, so we're doing this on a shoestring budget, but all of video files are kind of large, as it turns out. 1080p, those are like 30 megabit, and the 4K or is like 150 megabit. It depends a little bit. It's a variable. And so I had an opportunity basically to get it was an IBM NetApp that had been decommissioned, but it was like a backup storage pool, so it's only like SAS3, but it was 5 24 drive shelves, 2 terabytes each, and it had the drives had varying power on time, but we're talking about 18 months, give or take, of power on time, and also a Google search appliance was also decommissioned from another client, another project. But it's just a Dell R710. I just thought it was cool because Google search appliance. It's a Dell R710 that's been painted canary yellow by Google. And so that's a lot of fun. And so it's like, well, of course you have to run ZFS. I mean, there's no. It wasn't even a second thought. It's like I have to have ZFS for the file system. But then it's like, okay, how am I going to divide this up? Because each shelf has 2 controllers with 2 redundant paths. NetApp has their own way of cabling it that they suggest, and for mapping the drives. But it's like, well, I'm not really using the NetApp part of it anymore. These are just SAS enclosures. They're on the NetApp side. They're like QSFP plus connectors, and so you have to get the special cables that are QSF or QSF plus to the LSI mini SAS connector. So that's like the weird, slightly proprietary part, but it's just SAS. It's not any big deal. And so I decided I was going to keep one shelf for spare parts because God help me if I ever need to get a power supply or another controller board or something like that. And so we did a lot of experiments with like, what is the best way to arrange the disks, given that we're mostly going to be storing video. I mean, speed is important. We want to be able to do an editing workflow that's basically like a proxy editing workflow. So we will take the raw 4K files and stick them on the network, and we want to be able to get to them kind of fast. I mean, the server's got a 10 gig Ethernet adapter in it, and so it's like we've got 2 machines we can do editing from. And what like the ideal editing workflow turned out to be to create low resolution proxies that are on local NVMe disks in the local workstation. And then when it comes time to render, the rendering application will go back to the original source footage on the ZFS pool. But it makes me feel good knowing that it's on the ZFS pool. Plus, also offsite backup and things like that are really easy on the ZFS side. Now, I'd originally planned to use FreeNAS because easy button, and I used FreeNAS 10 to beta, but it wasn't quite ready yet, so I switched to Fedora. So we're using ZFS on Fedora, which is a little bit DIY. But with Fedora, we also ran Docker containers and some other stuff. I mean, we could probably do all this in FreeBSD too, but and so we have some Docker containers that are doing things like caching Steam and caching Blizzard and caching other different kinds of things that we might bulk download. So like for some of the stuff that we do, we might test a game on a system to see how fast it runs. And so it's kind of nice having 10 or 20 terabytes of games cached on Steam transparently for the entire rest of the network, just through DNS magic, and all that's on ZFS as well, different data sets. So that's worked out really, really exceptionally well.
Yeah, should do some kind of write-up or performance benchmarking analysis or something after the thing is built completely and put together.
It's put together now. It's I decided to turn it on one shelf at a time. So it's insanely way faster if you use there's 2 VDEVs per shelf, and it's insanely way faster if you use a bunch of them because there's 4 paths into the system, into the actual system. So it's 3 times 12 3 gigabit per second SAS channels into the chassis. So the performance varies a little bit, but we can saturate 10 gig Ethernet, and that's all we care about.
Cool.
Yeah, but if you do more VDEVs, you get more IOPS, right?
Yeah.
That's important. Yeah.
But
and in the chassis, there's a very small 8 drive mirror that it's a striped mirror. And that's what our virtual machines and containers and stuff run on. And so those are insanely fast.
Cool.
Indeed, yeah. So how do you stay on top of what's new in the IT industry? Do you have some special websites you go to, or magazines, or conferences? You mentioned this already.
Mostly follow guys like you guys. Read your books. Look at what you guys are doing. Lurk on mailing lists. Just read all the things. A lot of people bring us interesting stuff on the website, and I try to read all that. So mostly just a lot of reading and a lot of interesting stuff for what people are up to. The other interesting thing is that a lot of companies are getting more plugged into the whole, like Linux is not quite as weird, quote unquote weird, Linux and open source stuff in general. And so companies are a lot more willing to, like when Asus or Gigabyte put out a new motherboard or whatever, I'm usually one of the first ones to write them and say, hey, this thing doesn't work, or the ACPI tables are messed up, or I'm having trouble with IOMMU or whatever. And they've kind of gotten used to that. And so, but it's something that they take seriously now, which is really good, because I don't know that was true, 5+ years ago. It's like, the Linux thing, whatever. But now it's like, a lot of people are running Linux, and a lot of people are and we've got
customer base.
And we've got the numbers to back it up. There are a lot of students and IT pros out there that are using open source for their stuff. I mean, on the Mac side, it's really funny. Windows 10 at this point has a more up-to-date Unix environment than OS 10. Like if you're talking about Bash and the Bash on Windows, I mean, something is wrong in the universe with that. And so a lot of people are tired of that.
Some shifting going on. Yeah.
So it's really, 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 really terrible. And at this point, Linux and other open source operating systems are basically completely fine for anything that any normal person would want to do. It's not going to be exactly the same experience that you have on Mac or Windows, and some people still expect it to be exactly the same experience, and that is folly in their expectation. But in terms of those kinds of things, it's there. And so you can kind of be OS agnostic. It's like, okay, when I'm in this mode, I'm going to do this. When I'm in this mode, I'm going to do this. And for this, I'm going to run this other thing. And it's really not that much of a penalty to sort of learn and be productive in all of the operating systems, because that's just where we are today. I mean, depending on where you go and what you do for work and, what kinds of things you might need to run, there might be an application that you think is the best application that's only available on one platform. But I still think that there's going to be, at some point in the future, sort of a Promethean moment. Like something is going to happen with virtualization or SRIOV or something. And then at that point, what you're running for your hypervisor and what you're running for your applications is just not going to matter. I mean, are you guys familiar with like good old games?
Yep.
Yeah, Gawk.
Yeah. So you know how like they do like the old games where they just bundle DOSBox or they just bundle whatever with the game, and you download
it's totally in the background. No one sees it.
Yeah, you don't have to. It's just, I mean, imagine that with Windows games with like AAA titles with whatever. We're there basically. The enterprise has had that technology for 2-3 years now.
Yeah, even for video cards, like splitting video cards into multiple VMs.
Yep, yeah. SRIOV has been supported in the enterprise forever. VMware has done it well for maybe 5 years now, which is crazy for the workstation cards. And so I still think there's going to be a Promethean moment that could happen, tomorrow or 5 years from now. It just doesn't matter anymore. And it's like, oh, you want to run your applications and do whatever? It's great. Oh, Microsoft doesn't want to let me turn off telemetry and whatever, but I still have to use Windows for whatever dumb reason. Okay, just put it in a container. Good luck communicating outside the sandbox.
Although one project you might be interested in then on that kind of vein is something called Cloud ABI. Have you heard of this? It's a FreeBSD developer started it, but it's basically a new Unix ABI that you write an application to it, and it uses something similar to the Capsicum sandboxing that FreeBSD has, but it's OS agnostic. So there's a port of it to you compile the app once, and the binary will run on FreeBSD, NetBSD, and Linux currently. And I think maybe OS 10. I don't think so, though. But anyway.
Nice.
But basically, these Cloud ABI binaries have basically an alternative libc that you have on your different operating systems, and the one program just runs on any of them in the sandbox.
That's impressive.
Yeah.
There have been a lot of projects pop up like that that are it's not, I would not call it like a full application binary interface, but there have been a lot of really interesting things pop up like that all over the place. There's uh, I can't remember, like using QEMU and Windows with VirtIO VGA driver, but VirtIO doesn't translate the hardware calls directly. It translates them to OpenGL, but VirtualBox has a DirectX wrapper, like they've implemented their own version of DirectX, but that replaces the calls that would normally be directly to hardware or something with calls to OpenGL. So you can combine this library from Wine with the VirtIO driver for DirectX and actually get a DirectX to OpenGL translation wrapper that actually works surprisingly well. It's not compatible with every game, and some games are like, oh my god, DirectX is not installed because they detect it in some weird way, but it works surprisingly well. And it is like as close as you can get to an ABI with baling wire and duct tape in that it's functional and it works and it's not completely terrible.
Cool. Well, was there anything else you wanted to mention before we let you get back to your day?
I can't think of anything. Thanks for having me.
Yes, thanks for
Is
calling.
there any other questions that you guys have?
No, that was the end of our list of questions.
The long list.
Definitely the least accomplished guest you probably ever had, but that's okay.
Oh, wow.
I'll make it up with
There you
enthusiasm.
go.
Yeah, see? That works. Okay, so thank you very much for being on the show. And if you have news, then might as well invite you in the future.
Thank you guys. And if you guys ever need anything, just let me know.
Okay. Thank you.
Okay,
Take care.
thanks.
And cut. 56 minutes. Whoops.
Ah, and people start complaining that we're running long shows.
Oh, it'll be fine.
Sorry. I'm a
Yeah.
talker.
Interviews are no, actually, I think the people like the interview parts.
Yes, I think the
Because
interview
they
part is the
can
best
skip
part.
to-
This just makes up for the weeks when we
Yeah.
didn't have an interview.
Yeah.
I could definitely talk about the whole like Linux in school thing for like an hour just by itself because that story is so much fun. It's crazy.
Well, it's been
The,
really
the
interesting to
guys-
see the stories of how a lot of the developers we've talked to got started. Like the one was like, well, my brother set up the router running FreeBSD, and then he went off to college, and then it broke, and I had to fix it, so I had to learn FreeBSD.
Yeah,
Yeah,
it's like
small
I need to
moments
solve
in time
problems.
that change it all.
Or Doug Erling, who was a security officer a couple years ago, he was into the demo scene, doing those tiny little binaries that do all the crazy art, and he wanted something better than DOS to base it on. And so his friend gave him a FreeBSD CD, and then years later, he's the maintainer. He wrote OpenPAM, and was FreeBSD security officer, and does all this stuff, and works is the IT security officer for a university now.
Yeah, from Oslo.
There are definitely a lot of people out there that are very, very good at what they do, and it's those kind of stories are always interesting because it's like, oh yeah, this is a thing that I got from somewhere, and I just sort of ended up really spending way too much time with it, and then here I am 10 years later, and it's it's a career.
Most of them, it turns out, it's a story that could have just as easily happened to you, and it wasn't something special that turned them into this super
Yeah.
expert.
They weren't born with a special gift or something. It's just the effort they put into.
I really
the
wanted my
interest
internet to
they
work.
had.
to work and be good.
One thing led to the other. Yeah.
Okay, we'll let you get going. Thank you. We'll record the rest of the show.
Around the bits before and after.
Yeah.
You can probably edit that down a bit.
No, we don't.
It's
We always just do
It's
the whole
all
thing.
in there.
Like we cut off the first couple
That's why-
seconds of Benedict there, but after that, it's
Only if I screw
yeah.
up, then yeah. I get second chances.
It was nice meeting you, Benedict, and
Yeah,
if you guys
thank
ever
you.
need anything, don't hesitate to reach out.
Yeah,
Thank you
sure.
for your time.
We'll do.
Thank you. Thank you.
Bye.
Bye-bye.
You.
all right then. I'm gonna call
Wow.
you back so that we get a fresh connection.
Right.
Once I find the button.
Ta-da!
Hello again.
Ah, here we are.
Adjust my shot a little bit so my head's the same height as yours.
More or less. Yeah, they cut it a little bit in the videos so that my head is way on top, so there's no gap at the top. But
Well, no, they don't do that. That would have been me by accident.
yeah, well, I was just looking. I didn't watch the whole episode, but I was just scrubbing through.
So, yeah, how long has it been since you've not watched a whole episode of BSD Now?
Yeah, I thought I'd get some time last week in Oulu, but no,
Yep.
too much to do. It had a big program around the whole thing, so I barely managed to do two video conferences with, the project.
Yep.
But yeah, it was a nice week.
Okay, ready to go?
Sure. So are we doing this, one person doing FreeBSD, then one NetBSD, or should we switch every third or second?
Which way would you
item.
prefer?
So we could do, let's do, I think,
So there's 4 operating systems. Well, 3 operating systems in two operating
LLVM.
systems, a compiler, and an operating system that didn't do it. So yeah, I think maybe we take turns at whole topics. It'll just be a little bit less chance of us talking over top of each other.
right, yeah.
So do you want to do the FreeBSD one or the NetBSD one?
Let's see, the NetBSD one a little bit longer. And I cannot talk too much about each individual item, but I think I can do the NetBSD one.
Okay. Because yeah, I can talk a little bit more about some of the FreeBSD ones because I made
you're
most of
involved
this
in some
list.
of them, or
Although you were
by
there,
accident.
right? But you were there when we did it, right?
Yeah, in
In the basement
in
of
January,
the
yeah,
Carrefour
in the
or whatever.
hotel. Yeah, for FOSDEM. Yeah.
Yep, at FOSDEM. Well, before FOSDEM, but yes.
It's already gone.
Oh,
A couple of back.
the core thing. I suppose we could announce the core thing as well.
Oh, on the show, you mean?
Well, the thing that just passed.
Yeah. Oh, cool. That would be nice. Yeah, indeed. Mm-hmm.
Or we could
Yeah.
do it next week because the show's already kind of full. But we can put it in the feedback or something at the bottom.
Mhm.
I don't know. We'll have to pick.
Yeah, we should talk about a little bit more about it next week because you
We'll have
were also
the rest
part
of
in that.
the announcement written, so we'll have time to think about what to say.
Yeah.
Okay, so we'll do that next week. All right. Anyway, starting with GSOC. Okay, so do you remember how to do the opening of the show?
It's been already a week. We haven't done
2
it
weeks,
already.
yes, and you're not quite into it yet.
So it's BSD Now episode, what's it? Oh, 189. Do you like the title, by the way?
Sure.
Okay. And of course, recorded, and yeah. I think I can do this.
Okay. Yeah, so you got the episode number and the date and so on. Okay, ready?
Sure.
And recording.
BSD Now, episode 189, Codified Summer, recorded April 12, 2017. Hi, I'm your host, Benedikt Reuschling,
And I'm Alan Jude.
and we have a great show prepared for you today, and we're actually quite full already, so we should get right into the headlines. So what's the headlines for this week?
So this week's first story we got is looking at some of the Google Summer of Code projects coming up with the various BSD projects. So first we have the FreeBSD project, which has entered Google Summer of Code again. There. Okay. So with the number of projects going up for grabs, although I think the deadline to submit projects is over now. But the first one was to add support or to import the giant table bus DMA handler, grant table bus DMA handler from OpenBSD into FreeBSD. So if you're running FreeBSD as a guest on Zen, there's this driver that can improve things a bit, and OpenBSD has one, and so just importing that into FreeBSD is one of the projects. Interesting other one is USB dump file format, which is basically like TCP dump, but for USB buses, and adding that support to Wireshark and the virtual USB analyzer. That would be cool. Project that I've been involved with is writing a new boot environment manager. So basically replacing the badmin shell script with a library that can be more easily integrated with GUIs and so on, and adding support for thick boot environments, or what I've always called Brian Drury style boot environments, where instead of the boot environment being one data set, it can actually have children as well. So you can have, say, your user source and user OBJ for each of your boot environments be separate, so that when you walk back to an earlier boot environment, you get the corresponding user source directory instead of an updated one, and so on.
Cool.
And that requires a bit more work, and so putting that into a new boot environment manager library, which might also either enhance or complement the ZFS boot environment shell script or startup script that goes in rc.d that Alan Summers added earlier this year. But basically trying to clean up that integration to make boot environments even better and make the management of them easier and faster. One project proposed by Brooks was a basic smoke test of all base system utilities. So the idea with this one is just, run the basic stuff of this tool and make sure that it actually works. So we do a lot of our testing just by compiling things and see if they compile. But this could be as simple as running, tool -- version or tool -h, and just making sure the program actually runs and doesn't crash or say, can't run because of this missing library or whatever. So it would verify that the program was actually runnable. Not necessarily, going further that it actually does the right thing, but just a basic infrastructure so that any utility, we can just run a command and see that command still works, or doesn't not work.
Yeah, it doesn't give us a seg fault or something.
Right, doesn't say, well, it doesn't complain that the some library is missing or something. In lieu of, until we get, real tests for every program, this would basically be something more generic that could cover every program, even new ones that are created after that maybe don't have tests. Although most new things are starting to come with tests, which is better. But, this basic ability to run a test and say, with the change I made, have I made sure that everything works? This one I think would be especially useful for me. The other project I've been working on with Baptiste Tresson and Bernard Spill is changing the SSL library in FreeBSD's base system to be a hidden library, a private library. Well, part of that is going to be making sure everything still works after.
That would be nice indeed, yeah.
And that, we don't end up with something that ends up needing, or something that thinks it's linked to SSL when the SSL is linked to isn't there anymore, and so on. That'd be interesting. Next one, Christoph is backing a project to port OpenBSD's PF testing framework and the tests over to FreeBSD. So there are two different parts here. There's one that tests the rule parser, and another one I think that actually passes packets in and verify that they pass or fail through the firewall like they're supposed to, using virtualization. So getting both of those would be really nice. Even though the PF on FreeBSD is different, in the end, does the firewall block this packet or not? That test is not that different. Then Brooks also backed another project called the user space address space annotation. Basically, a tool to note portions of system calls with user space and validate them correctly. So there's a tool called Sparse, sparse.wiki.kernel.org, that allows pointers to be annotated as belonging to different user spaces. This is useful in kernels where user space programs require special handling, like copy in and copy out, and likewise memory map device addresses may require special handling and so on. And they want to use this in Cherry, their capability optimized version of BSD.
Yeah.
Bunch of other cool projects, replacing merge sort that's in BSD with something newer and faster. Another one that doesn't have a mentor currently, but was Kload. So there's this Kload feature to allow you to update FreeBSD without having to do a full reboot. It does kind of a half a reboot. And it's been sitting on the side as a patch for a while, and it needs to be tested and find out what's not working and get it fixed so it can actually be integrated.
Okay.
We'd also love to do, a kernel fuzzing suite, whether that's using the Trinity fuzzer that was recently run against Linux and so on, or using like the Triforce AFL thing that the people recently ran against OpenBSD's syscalls, and also using native tools like our memguard and so on to actually find bugs in the kernel.
Okay.
Another one was
What that looks like.
MFS BSD, which is a very popular project, but it generally only gets built by releases, and it's built by someone who's a FreeBSD developer, but they kind of built outside of the project. What would be interesting here is actually integrating it into the release build tools. So, for example, the snapshots that come out would also include an MFS BSD version.
Oh yeah, that would be
Yes,
helpful.
and also, for example, if you were to build your own release of FreeBSD, which I do all the time to test changes, right? After I'm done, I build an ISO and boot it in a VM.
As you should.
Yeah, or if I want to try it on my laptop, it'd be really nice to have an MFS BSD version of that without the extra work that it is currently. As usual, there's a bunch of cool projects for Beehive, a new NVMe controller emulation, so that you can have virtual
nice.
NVMe drives, even if they're not necessarily going to be as fast as NVMe. Being able to simulate that in Beehive could be quite useful. You'd also like to do verification of Beehive's instruction emulation. So using Intel's VTX provides very little assistance to the hypervisor when a guest issues a MMIO access, meaning that Beehive has to do a bunch of the work, and you'd like to use Intel's XED tool to make sure that what Beehive does is actually correct. VGA emulation improvements to Beehive. There's a list of things that could be improved there to make that better. There's that. The audit framework needs a test suite. Zen has a tool called OSS test that they would like to add more FreeBSD tests to, so that FreeBSD gets tested, or changes to Zen get tested on FreeBSD automatically.
Yeah, I think we saw that on VBSDCon, wasn't that?
And then Manu is backing a project to finish the work started in a previous Google Summer of Code to do bootloader backed with Lua. So replacing the loader's current force stuff with Lua. The Lua part mostly works now. The part that's missing is we don't, draw the menu and do all that stuff. There's also POSIX compliance testing framework. Looking at that. The core CLR, so actually porting Microsoft's .NET stuff into the FreeBSD ports tree.
Okay, yeah, for the people that need to have that as programming environment or a framework.
So lots of Google
Okay.
Summer of Code stuff. I think the official projects that get accepted will be announced in the next week or two. So there's that.
Okay, now we switch gears a little bit to NetBSD. So they have all their Google Summer of Code projects on their NetBSD wiki. It's wiki.netbsd.org. And they split it up a little bit into kernel level projects and user level projects, and also gave it difficulty levels. So we have easy, medium, and hard. And to start with, the kernel level projects. So they have no easy ones. Well, kernel stuff is always difficult, so they couldn't find any that is in the easy category. But the medium ones are ISDN and T support and Asterisk integration. So Asterisk is the PBX system where you can run your own telephony switch or your telephony network, and they want to have that integrated or add more support to it. And another thing is an LED and LCD generic API thing that should be from the description wise is that the design and implementation of a general API to control of LED and LCD type devices in NetBSD. And such an API would allow devices to register individual LED and LCD devices, along with a set of capabilities to, or the capabilities for each individual LCD that you might have. And the devices that wish to display any status information via LCD or LED would also register themselves with that framework as an event provider. So that would be one of the goals of that project. And another one in the kernel level section is NetBSD on Azure. So the goal there is to bring NetBSD to Microsoft Azure, their cloud platform. And the next one is OpenCrypto. So they have SW crypto enhancements planned for this one.
They would like
so SW crypto
to improve the multi-core efficiency and to switch some of the transforms like CBC and CTR mode for faster versions, either using their in-tree OpenSSL or from elsewhere like libtomcrypt, and then also add support for asymmetric operations like public key type stuff.
Mm. And the next one is similar to that one, or ties into the same region, which is scalable entropy gathering. Mm-hmm. So the kernel entropy pool in NetBSD provides unpredictable secrets, where it's definitely random and similar in other BSDs, for applications doing crypto, Monte Carlo simulations, all this. So they need a lot of random numbers all the time, basically. And it's a way to, or the project is about finding a way to do this in a scalable way with different sources, and having that with the more CPU and the more resources that your computer might have to gather these resources for entropy might be a good thing to have as a project. Userland PCI drivers is another one in the medium section.
So yeah, that one is using rump kernel stuff to actually develop drivers for PCI devices in user space instead of in the kernel. Because when you do something wrong in the driver, in the kernel, you panic the machine and you have to reboot, and that slows down the process of writing a driver by a lot. Whereas using the rump kernel and doing it in userland, if you crash the userland app, you can just restart it again and you can more quickly develop the driver that way.
So these were the medium ones and the hard ones. There are 3 listed here. So the first is real asynchronous I/O. And so what they write as a description for that one is that the current synchronous I/O implementation works by forking a background thread inside the kernel to do the I/O synchronously. This is a starting point, but one thread limits the amount of potential parallelism, and adding more threads falls down badly when applications wants to have large numbers of requests outstanding at once. So there's a need for increasing the asynchronous I/O in the kernels, but that's listed as a hard project. But still, if people are interested in that and have some knowledge in that area, why not take that one on? The next one is parallelize page queues. So the page queues, if the page will open, and give me a description here. Here it goes. So for many resource-intensive applications on NetBSD, the biggest bottlenecks in the operating systems are physical page allocation and mapping, specifically contention over the centralized queues of free pages and of cached pages that can be freed, and also acquiring references to pages that are already allocated. And they've broken that task into 3 independent milestones. And if you're interested in that, you can read a little bit more on that description. And the last one on the hard kernel section is tickless NetBSD with high resolution timers. So what NetBSD does is it configures a timer device to deliver a periodic timer interrupt, usually every 10 milliseconds, in order to count the time, wake threads up that are sleeping, all these things that are happening in the background, basically in the operating system, that needs some kind of timer to trigger that. So in the old days, this made sense when the timer devices were expensive to program and CPUs ran at megahertz speed. But today, CPUs run at gigahertz speed. Timers are on modern x86, ARM, MIPS, and all these other platforms that NetBSD runs on. They have hardware that is cheap to reprogram. Programs expect a greater than 10 milliseconds resolutions usually for sleep times, and mandatory periodic activity on idle machines wastes power. And that one also has 3 main milestones to be finished or to deliver, basically, if a student is interested in that. And userland projects
Yeah, let's try to go through these a little
also
quicker.
So we have easy ones in that one. inetd enhancements, add new features to inetd.
Yeah, that one actually looks kind of
Uh,
interesting. It's replacing the configuration files such that you can have a separate configuration file for each of the different services and tune some of the settings, like the rate limiting per service. Although rate limiting per service is already there in FreeBSD. I wonder how much different their inetd is. But the rest of those would also be really nice on FreeBSD.
Yeah, there's going to be a little bit of code sharing later on, I guess.
But if someone was interested in improving inetd, one of the ideas they also had was pre-forking. So currently the way inetd works is when somebody connects, it starts up the program and passes the connection to it. And then, so each connection uses a fresh copy of the program, which can be quite useful, but sometimes that's quite a bit of startup overhead. So the idea is to have some of them already running and then pass them the connection, but also possibly reuse an already running one instead of starting a fresh one for each connection. So, if you have 10 requests a second coming in or something, you don't want to start the program 10 times a second. You want to just, start 5 or 10 of them and just be like, okay, you're done. Here's the next one, and so on. But if somebody's interested in, especially the configuration change, doing that on FreeBSD, probably outside of Google Summer of Code, especially, if you don't qualify for Google Summer of Code, but you're interested in that kind of an easy project of just converting the configuration in inetd to use includes in separate files and so on, and then maybe do some of the other things on that list, do get in touch with me. I would like to see that happen on FreeBSD. I just don't have time to do it myself at the moment, but I would be up for helping someone do that.
Okay. And they also want to have a curses library, automated testing, so some kind of framework for curses. And the medium section has Anita support, Anita should support additional virtual machine systems. They also have a project to create an SQL backend and statistics query page for ATF test results, a lightweight precision user level time reading, query optimizer for find, port launch D, which is the always disputed or discussed at least macOS 10 utility, a secure PLT supporting rel row binaries. Going into that a little bit deeper,
it's a
might require a
security
little
feature.
bit of time. Yep. And sysinstall or sysinst alternative interface. And the hard section in the userland project lists only one, which is verification tool for NetBSD 32. There's also a couple of package source projects, but if you're interested in that, take a look at the webpage yourself in the wiki of netbsd.org. And that's all the NetBSD stuff here.
Next up, the LLVM project, which is BSD licensed for now anyway, but they have a bunch of interesting GSOC projects, and now that it's used in FreeBSD and OpenBSD and so on, it makes sense that if you're interested in some of these things, this is related stuff that'll help the BSDs, but isn't necessarily for a BSD project. But one they have is fuzzing the bitcode reader. The optimizer is about 25 to 30% slower when debug information is enabled. It'd be nice to track all the places where we don't do a good job about ignoring the debug stuff and making that even faster as well. Then they have thin LTO or link time optimization, propagating more global information across the program for more powerful optimizations, which is interesting as well. They want to extend Clang's AST to provide information of the types as written in template instantiation. So that'll be C++ stuff. They would love to get shell auto-completion support for Clang. Bash and other shells like ZSH support typing a partial command and then automatically completing it for the user when they press tab. This is usually only supported for popular programs such as package managers. Pressing tab after typing apt-get install late queries the apt package database and finds all packages that start with the word late. As of now, Clang's front end isn't supported by any of these common shells, and they would like it to be. So that one seems like an interesting one, especially if you know Clang, and it's definitely not overly difficult. A Clang-based C and C++ diff tool. Every developer has interact with diff tools daily. The algorithms are usually based on detecting, longest common subsequence, which is agnostic of the type of the content. A tool that would understand the structure of code may provide a better diff experience by being robust against, for example, Clang format changes. So it could actually tell when the change doesn't actually affect the code and treat it as white space changes, but also oftentimes what you see with a diff is when you add a new function or something, the diff takes one line from the previous function and modifies it and stuff. Whereas if it actually used Clang and the libllvm stuff to learn more about the code and know, okay, what effectively happened here is they added this new function, so I can actually shift this diff a little bit and be like, this is what actually changed. So rather than just comparing the text and finding the biggest chunk of change or whatever, you could actually understand that this is C, and so what they actually changed is this. That would be really cool.
Indeed.
They have one to just go through the code and find any places where pointer is dereferenced without checking if it's null first.
Yeah, the typical pointer mistakes.
Create warnings if virtual calls are made for constructors or destructors. So that's a path-sensitive checker that will warn if virtual calls are being made for things that shouldn't be, like the constructor and destructor, which are not valid as pure virtual calls and could be a sign of a user error, and so on. They'd also like to improve code layout. Their goal of this project is trying to improve the layout and performance of the generated executables. So not actually the code in the repo, but how it actually writes the binary. The primary object format considered for the project is ELF, but this can be extended to include other objects, and that will actually touch both LLVM and LLD, the linker. And they got a bunch of other projects, but those are the interesting ones.
The most important ones, yeah. People can check our show notes for more details.
Yep.
And last but not least, OpenBSD. So OpenBSD put out kind of a mail or a reason why they aren't participating in Google Summer of Code 2017. Bob Beck wrote that into the OpenBSD MISC list. Basically, it's about, they tried it for 2 years. It was too much effort on the part of the foundation organizers, the OpenBSD Foundation, that is. The mentors there, they had to deal with all the bureaucracy involved and didn't really see enough return in terms of new developers to the OpenBSD project, which, frankly, in his opinion, being selfish on OpenBSD's part is the only reason for them to do it. Well, it's not too far out of the way.
Yeah,
and,
it's interesting there. Yeah. Whether the question is the Google Summer of Code stuff actually worth the time that it takes away from developers that maybe would have developed something on their own in the meantime and so on. Every once in a while, when I see so many abandoned GSOC projects, I think that maybe it's not worth the effort. But then when we interview people, it's a number of FreeBSD developers who've gone on to do great things got their start with GSOC.
That's where they got introduced to the project and the people there, and it's a trial period, and people see whether not only the technical parts are interesting to them, but also the project itself. But if they don't like it, they don't have to stick around after Google Summer of Code is over. Mm-hmm. But for most of them, it's actually the best way to introduce themselves into the open source community and also into the project. And most of them are actually more interested in continuing what they started in the project and become developers over time.
Yeah, like I know Conrad, who we interviewed recently, was a Google Summer of Code originally. Edward Traz at FreeBSD also, and a bunch of other people. So at least somewhat, we've definitely gotten good things out of GSOC, although there's a couple of times where the projects haven't maybe been worth the effort, but you can't tell that until it's too late.
Right, or that it's over, or people are starting to disappear. It's also, students still have their academic stuff to finish, and maybe they pop up again after their university career is
Yeah.
mostly over. And it's always interesting to see when people come back and say, hey, I was in Google Summer of Code way years back, and I just want to return, and now I have more time for this. So this is the OpenBSD side of it. There's also an additional Y Combinator Hacker News thread about the whole
Bit more
discussion, which
discussion,
is
right?
way too long to cover here. But if you want to read through that, it's in our show notes.
So the next story we have is an interesting one. It's from the Dtrace blogs. This is one by
What's it
Robert
called?
Mustache.
Adam Levin?
And it's called the Turtles on the Wire, Understanding How the OS Uses a Modern Network Interface Card.
Okay,
So-
where are the turtles on the wire?
Yes,
I
the
don't have
turtles,
any.
I think it just means it's why it's slow.
Okay.
But
Yeah,
it
that
mostly
makes
just
sense.
starts with the modern networking card has evolved quite a bit from the simple Ethernet cards of yesteryear. As such, the way that the operating system uses them has evolved in tandem. Gone are the simple 10 megabit copper or BNC devices. Instead, 1 gigabyte per second is commonplace in the home, and 10 gigabytes per second rules the server. And you can buy cards that can do 25, 40, 50, or 100 gigabits. And at that level, that's a big difference, going from 10 megabits to 100 gigabits. Obviously, the driver gets a little more complicated. But he says, for this entry, we're going to focus on how the operating system actually sees the network card, what abstractions they provide together, how things have changed to deal with increased tenancy and performance demands, and then finally where we're going to, where we're going to go from here. But it covers the beginning. You have a simple NIC, which has a MAC address, and it's used to filter incoming packets. So if the packet's addressed to some MAC address other than mine, I just ignore it and don't take it off the wire. Then you have a ring or circular buffer for packets that are coming in, and then you have one for packets you want to send out. Then you have the ability to generate interrupt to tell the CPU, hey, I need attention because there's a packet here. And then, a way to program all the above, generally with PCI memory mapping registers and so on. So it
This
comes
would be
with
a nice introduction to networking for undergraduates. Like, how does a NIC actually work internally, and what the operating system does to pick up all these packages.
but it walks through it all, like the problem where you have a single busy CPU, and you kind of get into this idea where in FreeBSD 4 we introduced the idea of polling, where instead of the network card sending an interrupt and making the CPU stop what it's doing and pay attention to the network card every time a packet came in, where you could have thousands of times a second. Polling was, how about once every 1,000th of a second we asked the network card, do you have any new packets for me? This mitigated the problem of the interrupt storm. Of course, now NICs have interrupt moderation where they're like, oh, if I've already sent an interrupt in the last couple of milliseconds, why don't I just wait and send another one in a couple milliseconds instead of flooding the channel with, hey, I need attention. But then it covers things like the problem with density when you get more NICs and so on, and then virtual NICs and MTUs and VLAN tags, and what happens if the device is always in promiscuous mode, where if you have multiple VMs running, then the NIC on the host has to have all of the virtual MAC addresses on its list of packets it'll accept, right? And then you get the problem that turns out CPUs are too slow. Or the interrupts are coming in too hot and we're missing some of them or whatever. And then, so one solution is do less work. The other solution is to turn off the interrupts. And that's how you get polling. And then it kind of recaps some of it, and then it talks about the future directions and links you to some other reading you could do if you really want.
Okay.
But very detailed, great way to get into it and start to understand some of the things that are actually going on. Why that 10 gig NIC costs more money and why the driver is more complicated and so on.
Yeah, well, we cannot just use the same
Techniques we
old
did with the
network
10
techniques we did,
megabit
yeah.
cards. Yeah.
Yeah, new devices need also new code, I guess. Yeah. Yeah. So if you're interested in that, read through that article and check out the papers and links they have in there. That's a good read up for the more technical folks who want to get into, driver development and
so
things like that.
just understanding what's happening or where the problems might be when your network isn't going as fast as you would like.
Okay. So our next story is called Make Dragonfly BSD Great Again. So, well, this already has some interesting undertone, but it's about basically finding a bug in Dragonfly BSD code, as far as I understood.
Yeah, so I can go through this one, I guess. So the author, whose name I'm going to butcher terribly, but Maciej Kosilski, a nice Polish person, says, recently I spent some time reading the Dragonfly BSD code. While doing so, I spotted a vulnerability in the System 5 semantics subsystem that lets users point to any piece of memory and write data through it, including in kernel space. This can be turned into execution of arbitrary code in the kernel context, and by exploiting this, we're going to make Dragonfly BSD great again. So in his little preview here, you can see he runs uname -s, and it says this is Dragonfly. And he does ID, and you can see he's running as the user SHM with UID and GID 1001. So he's running as an unprivileged user, and he's running on Dragonfly. Then he runs the first little program he wrote, which he called shellcode 3. Then when he runs uname -s, it says it's FreeBSD, not Dragonfly. Although, as we'll see later, he could have made it say anything. And then he looks at the message queues and so on, and then by modifying some stuff and running some commands, now when he runs his other exploit, /final, he runs ID and he sees that he's actually now UID 0 and GID 0. So he's running as root.
Which is root.
So he's just turned his shell into a root shell by running this command. So how did he do it?
There's a bug.
Yeah. So it says Dragonfly BSD is a BSD system which originally came from FreeBSD. In 2003, Matthew Dillon forked the code of FreeBSD 4.9 and created Dragonfly BSD. The author of the article here says, I thought of Dragonfly BSD as just another fork, but during EuroBSDCon 2015, I accidentally saw the talk about the graphics stack in Dragonfly. I accidentally went in the wrong room, but it was too late to escape, and I was sitting in the middle of a row, and the exit seemed like it was light years away.
Okay.
Anyway, this talk was assigned to me that it's not just some niche of a niche of a niche operating system. And then, after hearing about the graphics, he dug into it more, and he spent time learning about the Hammer file system and Dragonfly's approach to multiprocessing, process snapshots, and all the other cool features of Dragonfly. He says the Wikipedia article is a good starter on just what some of those are. And so suddenly he was interested in Dragonfly. So he says the bug itself is located in the semctl system call implementation. And he has the code for it up in here on the screen. And you can see it does a B copy from the pointer, or from the area that's specified, to the kernel from a pointer specified by the user. So he says that the B copy on line 385 copies the semid DS structure to memory pointed to by argbuff. This pointer is fully controlled by the user, so it's one of the syscall's arguments. So that means the user can tell the kernel, hey, copy this data to anywhere.
Wherever you want.
So the bad thing here is that we can copy things to arbitrary addresses, but we have no idea what we copy yet. This code was introduced by wrongly merging code from the FreeBSD project. He says, bugs happen. But he says, for now, let's try to trigger the bug, just to see, make sure we're doing it correctly. So he has a short little sample program here, and you can see he creates a pointer to an invalid space in memory, just called, dead, or dead code, or whatever you want to call it. Then he creates a shared memory segment, and then he tries to copy that to that pointer. And so we're going to copy data from the shared memory he just created to the pointer dead. which is likely unmapped. So the kernel should panic. So when he runs the little program, you can see it actually panics because he's page fault while in kernel mode, writing to kernel memory that's not mapped.
Yeah, that you shouldn't be
So
able to
now
write to.
he wants to do it with things he controls. So in this case, he can play with it a bit more and actually copy data he wants into the random memory. So it says Dragonfly
Targeted.
BSD lacks the SMEP and SMAP implementations, which means that we can execute code placed in the user's pages directly from the kernel space. Now we're going to make a dumb decision. We're going to overwrite the open function pointer with a different one. So what he does here is get the memory address of the struct that's going to have the pointer to what to do when you try to open a file, and replace it with a different one. So in his first example, he just has a little script that just does a for loop and basically hangs the machine. So now when he calls open on that file, it just hangs the machine. So instead, the second time what he does, after he overwrites the function calls for the open, is he overwrites the OS type global variable with the other one. So in this case, he
That's what we
overwrites
saw.
Dragonfly with the word FreeBSD, although he could have overwritten it with any string he wanted.
Anything.
As long as it was shorter or the same length as the word Dragonfly, because that's the size of the memory allocation. So with that one, we get that first result where you run it and all of a sudden, the machine claims it's FreeBSD, or you could have made it say Linux or Solaris or Illumos or whatever. You can make it say Windows. There you go. But that's just playing around. So then he's got dear Ring 0, I want to be the root. So with this one, after you override that open call, you use the reference it gives you to the credentials of the user that opened it, and you change those to make the user's UID and effective UID 0. So now when you run it, you see that after running it, you instead of user ID 1001, you're now user ID 0, and you have root. It's like,
Okay.
whoops.
But there's a happy end to that?
Yes, this is the bug was fixed very quickly within a few hours by Matthew Dillon, and Dragonfly version 4.6.1 was released shortly after, and it seems safe now.
Okay.
If you like this article and want to be notified about other stuff, you can subscribe to him on Twitter.
Okay.
He also
so
gave a
that's-
talk about this at a conference in Warsaw,
Oh, right. Okay. So there's a
a video as well.
recording of that, like on YouTube.
Yep, there's a link at
references
the
here?
bottom of
Okay.
the show notes.
Yeah. So check that out if you're interested in the details and test it on other operating systems. There might be similar problems there.
Yep.
You never know.
This week's episode of BSD Now is brought to you by DigitalOcean. So if you ever need to host something, it's pretty hard to go wrong when you can get a FreeBSD machine from them for $5 a month. Or if you
Yeah.
need a bigger one, they have
Backed
bigger
by
ones.
SSDs.
They have
Yeah, and
whatever
they help
size
you
you
a
want.
lot with, managing your infrastructure. Like they have, first of all, they have monitoring, which is very comprehensive. They also have a simple API where you can control your droplet.
Well,
which is
especially
your
if you're going to have
virtual
many
machine.
droplets.
Yeah.
That's the problem you will find is that once you spin up a $5 droplet to do something for you, you'll be like, wow, that was easy and that worked so well. I need another one and another one.
And another one. And another one.
And very quickly now you have a fleet of them and you would like an API to manage them. And they have that. They also have a load balancer. So if you use multiple small ones, you can actually balance the load between them and say only spin up additional ones when you need them, right? Like, depending what you're doing, maybe your site's only actually busy during certain 4 hours of the day. Well, you can keep the site running on a cheap $5 one most of the day, but when it gets busy, you can spin up a $10 or $20 beefier one or a couple of them with the load balancer and use them during the peak time and then go back to saving money during the off time. And the best part with that is with hourly pricing, you don't pay for the entire month for those ones you only spun up for 4 hours a day. You can pay, the $10 one is 1.5 cents an hour.
Which is super cheap. Yep. And if you need a little bit more storage to that one, you also can get up to 16 terabytes of storage or volume to your Droplet.
Yes, you can get
which is,
separate block
I think,
storage.
Most
which is very nice because you pay per gigabyte there, so you can just spin it up, make a ZFS pool on it or whatever, and then you can grow it over time as you need it. And so you only end up paying for the storage you're actually going to use. It solves the biggest problem people had is like, well, it's nice that you have 20 or 30 gigabytes of SSD storage included with the $5 or $10 one, but I want to store more stuff. And, I don't really need SSD speed for it. It's like, well, you might as well have the SSD speed. And if you want bulk storage, hey, turns out we have that. You can rent it per gigabyte.
Right. And combined with that, they also have lightning fast networking. So each hypervisor has a fault tolerance and redundant 40 gigabit per second network to ensure that the uptime of your Droplet is there. And also, in peak hours where you have a lot of network traffic, maybe you're running a web shop or some other busy website on your Droplet, then they can provide the actual throughput to serve your users.
Yes.
That.
They also have team support, which is great. Not necessarily just for businesses, but we use it for like our IRC network. We have a couple of servers there, and we need more than one person to be able to have access to them. Well, instead of having to share passwords, we use the team support, and my account can just access the droplets of the people who have allowed me. It's very nice. Anyway, check it out. Go to DigitalOcean.com. When you sign up, use the coupon code FreeBSDNow, and you'll get a $10 credit added to your account. So you can use the smallest Droplet for 2 months, or the next one for 1 month, or you can run the $20 one for half a month, or you can run a $100 one for a couple of hours, whatever you want to do.
Yep. So check out DigitalOcean and the products and solutions that they provide.
And cut. Okay, we'll come back with the IX ad in a minute, but first I need to check out for 1 second. Be right back.
Break never hurts. Oh, I was disconnected in the meantime. Oh, great. Oh, but I'm back. Oh, here come the long ones.
Long what?
The the next 2 stories alone take
Yeah.
roughly 2 pages.
Try to go through them a little quicker, though.
Yeah, just to
Because,
most
we took a
important
little too
parts.
long on the Google Summer of Code ones.
Yeah, but they are long in themselves. But yeah,
Yeah, it's just, the Google Summer of Code ones, I think, are slightly less interesting than these later stories. But anyway, ready?
These are the YubiKey ones and the
VLAN one.
all right.
And recording.
So I hope you enjoyed our interview, and we're going right back into our little section called the smaller but yet interesting bits of BSD that happen in the meanwhile. And well, the first thing is called using YubiKeys everywhere.
We got to do the IX ad first.
Oh,
And
right.
also,
Yeah.
It's called the news roundup.
Yeah.
Okay, anyway.
IX, yeah.
This week's episode is also brought to you by IX Systems, your ultimate ultimate place to get your servers for open source.
Yep. Whether it's a NAS or a full rack or an all-flash storage, IX Systems can provide all kinds of solutions to your needs.
Yeah. The best part, I think, is the white glove support. Had a disk fail, had the new one 2.5 days later, swap it out, no problem. It was great. They could ship the replacement drive directly to the data center. So, I didn't have to deal with that. It's just so nice. Very well done. And then, every time I need more hardware, it's like, hey, I need 2 more video transcoder boxes. They're like, okay. And it's like, yeah, it looks like this. It's like, watch out. There's a RAM shortage going on right now. So, but don't worry, we got you covered.
Yeah. Some vendors don't even tell you about that. They just, dump some hardware on you and think you're happy. But IX System is really interested in providing the exact solution for your problem that you want to solve with that machine. And they have the experts on staff that can tell you what kind of different configurations you could run, what kind of alternatives there are. So you have a better way of deciding which is the best solution for you.
Yeah. Basically, you talk to them, tell them what you need to do. They help you design a system. Then the best part, they test it and burn it in for you for 3 days to make sure everything works before they ship it to you. That makes a big difference. Much higher percent of your servers end up just working and not giving you any trouble than, if they didn't do that. So I definitely recommend checking them out. Make sure you tell them that Alan and Benedict sent you, and they will treat you extra nice.
Yeah.
So our first story this week is about using YubiKeys everywhere. Another great article by Ted Unangst. In particular, he's interested in YubiKeys, and so he tried them out and wrote up his feelings about it to save you maybe the pain of doing it yourself.
Mm. So he tried different, applications for it, like using it on special sites or some like system logins or what kind of other needs you might have to use it for. And he wrote up basically all his experiences in a nice blog post that he, which is kind of long, but interesting enough.
Well, yeah, because it covers quite a bit of different things. So first, he has 2 different YubiKeys. You got a YubiKey 4 and a YubiKey Nano, which is much smaller. So he tried both of those. He tried them on Chrome OS, Windows, and OpenBSD. And then he tried it for logging into the computer and logging into websites and services and using his phone. So he did quite an array of testing for you, which is quite good.
And these are usually the use cases where you might use these. And you also want to have a little bit of convenience, but also the security that it provides to securely log into your systems or authenticate you.
Yeah. So he says, everyone is getting really excited about YubiKeys recently, so I figured I should get excited too. I have so far resisted 2-factor authenticating everything, but it seems like another fun experiment. There's a lot written about YubiKeys and how you should use one, but nothing I've read answered a couple of the specific questions he had. He says, it's no secret that I take a dim view of 2-factor authentication, although most of those gripes are with the implementation, not the concept of 2-factor authentication. And a lot of those remain true. Where 2-factor auth perhaps might succeed is in limiting the damage of phishing attacks. I like to think that, think of myself as a little too savvy for most phishing attacks, but it's sadly true that most phishing victims felt that way until they were a victim as well. It's like,
Yeah.
but most people don't read
Slip.
their mail in a terminal and rarely have to copy and paste things, and don't use webmail and don't have colleagues sending PDF files to them and so on. But anyway, so he began by ordering 2 YubiKeys, the regular YubiKey 4 and one Nano. And he wanted to play with the different form factors to see which one was better for various uses. And he wanted to test having a key and a backup key. Everyone always talks about having a YubiKey, and then what happens if you lose it? Terrible things happen. Can this problem be alleviated by having 2 keys? He says, I'm also very curious what happens when I try to log into a service with my phone after enabling universal 2-factor.
Yeah, these are scenarios that are common, but should be tested before you rely too much on these devices.
Yeah. So he says, I've got 3 different computers, each with a different operating system in the mix, along with a number of mostly web-based services. Wherever possible, I want to use the YubiKey both to log into the computer and to authenticate himself to the remote service. I'm somewhat split on a decision to use the YubiKey for 2-factor versus an alternative factor, and he'll consider either of those. So he started his adventure on his Chromebook. His ultimate goal was to use the YubiKey for local logins, either as a second factor or as an alternative factor, meaning that with the YubiKey he wouldn't have to type his password, or where we need both the YubiKey and his password. First thing first, you need to get the YubiKey into the account I want to sign into the Chromebook with. Alas, there's apparently no way to enroll only a security key for a Google account. Every time you tried, it asked him for his phone number, which he doesn't want to give to Google, because he doesn't want it to switch his password reset to work with his phone. Because he
Makes
doesn't
sense,
consider his phone to be secure, or it's the most likely thing of his that he's going to lose. Right. So he couldn't figure out how to get it to go on the Chromebook without doing it, without taking his phone number and doing SMS authentication as well. He says, meanwhile, on my laptop, I had a notification about I've scrolled too far. I skipped something. So then he tried the 2-factor auth for Facebook. Facebook sign up using U2F is pretty easy. Go to account settings, security subheading, add the device, tap a button when it glows, and your key is added. Note that it's possible to add a key without actually enabling 2-factor auth, although later in the article it turns out it only worked because he had previously added his phone number.
Okay,
Or
already.
used the phone app or whatever. He says that you can still log in with only a password, but there's no way to log in with no password and only the USB key. He says logging out to confirm that it would actually check the key and everything looked good, so he killed his other active sessions. Now with the phone test, it didn't go quite as smooth. He tried to log in. The Facebook app tells him that it's going to send him an SMS and to enter the code in the box, but Facebook doesn't have his phone number, so they couldn't send an SMS. But meanwhile, on his laptop, a new notification popped up saying, your phone's trying to log in. Do you want to allow it? And he allowed it. So he followed the prompts to confirm that he's him and that he wants to permit the phone to log in. However, that doesn't have any effect on the phone. He had to go back on the phone and then try to log in again. And then, after entering his password, it's like, your login was approved by your computer. You can go in. So everything works, but there's still some rough patches in the login flow.
Back and forth.
Ideally, the phone would more accurately tell me to visit the desktop site and authenticate that way. And, is that good enough? It's like, if you want to access it on your phone, you just can't now, right? He says the Messenger app also crashed after telling him that his session had expired, but upon restart, it borrowed the Facebook app credentials and was back in and everything was fine. He says later he logged out and in again on his phone with just a password because the approval process, I had selected the option to remember the device. This is somewhat confusing because the message appears in Chrome and refers to this browser, which is apparently talking about an app on his phone. Whoops. Doing it over, he would probably choose not to remember the phone. He says, I trust my phone, but if I log out of Facebook on my computer, it's for a good reason, and I want my phone to be logged out too.
Right, yeah.
So overall, Facebook mostly worked. He says, trying to configure Dropbox. Dropbox won't let you add a security key to an account until you've already set up some other mobile authenticator. He said he already had a Duo app on his phone, so he picked that. And after a short QR scan, I'm ready to add the YubiKey. He says, so the key works to access Dropbox via Chrome. Accessing Dropbox via my phone or Firefox requires entering a 6-digit code. There's no way to use the YubiKey in that 3-legged configuration.
Okay.
He also says, I don't use GitHub, but I know they support 2 factors, so try them next. Very similar to Dropbox, in order to set up the key, I must first set up an authenticator app. This time I went with Yubico's own desktop authenticator. So instead of scanning the QR code, you type in a giant number on your Windows laptop, and it spits out an endless series of 6-digit numbers, but only while the YubiKey is inserted. I guess that is kind of what I want, although a 3-pound YubiKey is kind of unwieldy because you have to plug the YubiKey into the laptop and to use the desktop authenticator. He says, for the online service review, okay marks for Dropbox and GitHub, but he would prefer some means of enrolling only a YubiKey instead of using it as an alternative. Some incomplete UI interactions aside, Facebook seems to be implemented exactly what I want. I can log in with the key without needing anything else. For devices like my phone, this requires configuring a one-time or every-time approval from your laptop. Possibly cumbersome, but it's actually easier than typing the temporary one-time password tokens in, and less stressful since you're not racing a clock.
Right.
So hopefully these are true second factors and not actually single factors that can be used to perform a password reset. So for his next experiment, he noticed that Dropbox verifies your password before even looking at the second factor. He says, I have a feeling that they should be checked at the same time. No sense allowing my password guessing attack to proceed while I plot how to steal someone's YubiKey. In a sense, the YubiKey should serve as a salt, preventing me from mounting an attack against the password until I've gotten the YubiKey, thus creating a race where the victim notices their key is gone and revokes access from that key before they can brute force the password. So that's how he thinks it should work. If I know the password, the instant I grab the key, I have access. Along similar lines, I was able to complete a password reset without having to enter any kind of security code. So apparently didn't need the YubiKey in order to reset the password, which is probably not good.
Yeah, that's not your intention.
Yeah, this is in the course of writing this up, I went back and had another look at Facebook settings. He says, I also have a code generator installed there, which is yet another temporary one-time password implementation. He says, I must have set it up in the past and forgotten about it. He says, doing everything again, Facebook won't let me enable 2-factor without configuring a mobile app as a code generator. So the above is partially wrong. Anyway, still bonus points awarded for letting me use the authenticated desktop session to approve other logins. Ideally, these 3-legged setups would re-verify the U2F key is present before allowing you to authorize the phone. Facebook did allow me to approve my phone login without pressing the button on the YubiKey. I'm a little confused, though, how the Facebook mobile app generates login tokens for itself. I guess there could be a bug there, but in particular, he would like to be able to have his phone not logged in when he says go through an airport or whatever. But also, he's a little confused about the Facebook mobile app generates login tokens. He says, there could be a bug here where if you only have the mobile app generator and you log out of Facebook on the phone, how do you log back in order to run the token generator?
Yeah, so...
Wonders if anybody's ever got locked out of their account that way.
Yeah, not completely.
Yeah, and he says, having my phone turn into a second factor is a big part of what he's looking to avoid by buying a YubiKey. I'd like to be able to take my phone with me, logged into some sites, but not all, and unable to log into the rest. All of these sites require some use of my phone or mobile authenticator, and that makes that difficult. I bought the YubiKey because it was cheaper than buying another phone. He says, using the Yubico desktop authenticator seems like a way around this, but then you have the whole laptop.
Yeah, you have to drag that around with you all the time.
So then he shows configuring Windows to let you log in with the YubiKey. It mostly worked, except for you also had to create a PIN, and the PIN is not very long, and you can use the PIN without a password to log in, meaning that it's not very secure. He doesn't like it. And then he walks through the configuration of doing it on OpenBSD.
So apparently this one includes a YubiKey OTP login support out of the
Yes,
box.
there's
is
the modules
OpenBSD,
built in, although
of
you
course.
still have to do some work to use it. And also, when you log in as username : YubiKey in order to tell it to use the YubiKey. Or if you're using something like Xlock that only asks for a password, you do YubiKey : password. And apparently his
Okay.
password is banana spray.
I guess it's not its real password, but for this blog post.
And he says a few notes about the one-time password. As mentioned, the secret key is the real password. It's stored on whatever laptop or server you log into, meaning any of these machines can take the key and use it to log into other machines. If you're using the same YubiKey to log in both your laptop and a remote server, your stolen laptop can trivially be used to log into that server without the key, which doesn't seem like a good thing. Be mindful of that when setting up multiple machines. Also, the one-time password counter isn't synced between machines, meaning there is a limited replay attack. One extremely simple alternative is to continue using SSH keys, but the program the YubiKey does for the, but program the YubiKey with a passphrase that unlocks the private key, thus tying access to the YubiKey. This isn't really a great idea, but I wanted to mention the static passphrase feature because it works with Software Crypto for decrypting the hard drive on his X1 Carbon as well. He didn't use the SSH key feature built into the YubiKey because it doesn't support the newer ED25519 SSH keys, and he just switched all of his keys to that and doesn't want to switch again. And he says only RSA keys are supported, although they claim they're adding some ECCP curves in the future.
Yeah, which means you have to buy a new device, basically.
He says, comparing the way OpenBSD and Windows do things, Windows is a little more transparent. The presence of the YubiKey is invisible, and yet I would like the OpenBSD way of allowing YubiKey to be the sole authentication factor. Some people use passwords. I prefer epic pass poems. So it's longer than a pass phrase. He has a pass poem detailing the rise and fall of REO Speedwagon. He says, I'm fairly confident I'd like to keep this as a sole backup login mechanism, but I'm happy to find an option that works a little faster day to day. Then he has some thoughts about comparing the two types of YubiKeys, the bigger one and the smaller one. He says the bigger one is probably more useful, but the small one is nice. And you can leave it permanently attached to your laptop, and it's very, very slim, so it doesn't catch on the laptop bag and stuff. And yeah, but anyway, it's worth reading the whole thing if you're interested in a YubiKey and what the gotchas of that might be.
Yeah, to integrate into your authentication methods. Okay. So the next one is called What Happened to My VLAN? This is basically a blog post about an observation about performance degradation in VLAN setups in networking in OpenBSD. So it says, or it starts with a long-term goal of the efforts I'm driving, or the person that wrote that blog post, is to unlock OpenBSD's network stack is obviously to increase performance. So that it's understandable that if you find it confusing when when some of the changes introduce performance regressions. So he says that there's an observation going on that when you do a certain setup, which is or is involving a Xeon box, and he provides the specs here, and that one has a forwarding performance without the PF dropped from 1.42 mega. What's this?
Million packets per second.
Yeah, million packets per second to 880 kilo packets per second.
So that's basically, yeah. So when you add a VLAN to the forwarding path on OpenBSD, the newest version, the performance drops from 1.4 million packets per second to 880,000 packets per second. And mostly it's a temporary degradation while they're reworking the network stack to make it unlocked. So while eventually unlocking the network stack will make it faster, currently, with the changes that have been committed versus the parts that aren't finished yet, it actually makes it slower
Okay.
by rather a
So the
lot.
question,
But
yeah.
why?
and the question is, where is it coming from? Yeah. So they asked him to profile the kernel while executing such tests, the forwarding. And with the data that were collected, he says, or he writes, I generated the graphs below using gprof2dot, which gives you some nice graphs to look at where the dependency graphs are and some more information about, paths that were taken. From left to right, CPU 0 to CPU 5. So on the web page, you can click into those and zoom into to find all the details where all these threads are being started and what kind of, individual performance they contribute to the whole system there. And it goes on by describing the graphs that, as you can see, the current architecture, the network stack already uses more than one CPU. CPU 0 deals with interrupts, empty network interface rings, and passes packets to CPU 1 via IF_input. Then CPU 1 processes the packets in the process context and finishes by enqueuing them via IF_unqueue on network interface rings. And with VLAN, the situation is now that from a userland point of view, they started with some low-hanging fruits. First of all, we can see the effects of the recent preempt change. Only CPU 4 in the first case and CPU 5 in the second case are executing syscalls. If I already showed you some similar graphs, you certainly remember that userland processes were jumping between CPUs. We also see that the favorite scheduler hack, or the recent one, is working as intended. And since CPU 0 is not executing any syscall, even if has enough free time to do so. And then it goes on to describe the lost percents, where this is actually coming from. So the first measurements that were done were noticing, or the people who did this noticed that a drop of forwarding package of roughly 50%, which is already a lot.
Well, yeah, it was, that's especially when you add the performance overhead of doing the profiling.
Right, that's also a part of the measurement that you have to do. So, however, when doing some profiling, he noticed that without VLAN, the machine could only forward 730K PPS. So gprof profiling has quite a huge overhead, as you can see on CPU 1. There's another graph there.
dtrace.
And with dtrace is coming into the equation here very well, because it doesn't add the actual measuring overhead.
Well, it does. It's just a lot smaller than that.
Right. And it doesn't skew the measurements too much. So with VLAN, the machine could only forward 490K PPS. That's roughly only 2/3 of the measured plane performances. So let's assume that the number of packets forwarded per second is mostly bound to the amount of work CPU 1 can do processing such packets. In this case, we're looking for functions where CPU 1 spends between 1/3 and 1/2 of its processing time in the VLAN case. Without a surprise, we could guess that they are the following. And there's another graph there.
So it says, with some measurements, a couple of nice pictures, a bit of analysis, and some educated guessing, we now are now measured of saying that the performance impact observed with VLAN is certainly due to the pseudo-driver VLAN itself rather than some other part. But a decrease of 30 to 50% in performance is not what you'd expect from a pseudo-driver like VLAN that's not doing that much work. So it's originally heard that the reason for this regression was the use of SRP, which is I think that's the new routing thing they're using, right? I forget what that is.
Yep.
But by looking at the profiling data, it seems that the problem is actually the new queuing API. In the graph above, the CPU time spent in if input and if enqueue for VLAN is impressively high. Remember, in the case of VLAN, these operations are done for every single packet. When if input is being introduced and the queuing API did not exist, the putting and taking a simple packet onto or off of an interface queue was a cheap operation. Now it requires a mutex per operation, which is, in the case of packets received and sent via VLAN, means grabbing the mutex 3 times. He says,
yeah, that's the locking overhead.
He says, I can't say if my analysis is correct or not, but at least it can explain the decrease in performance observed on the Xeon when testing multiple VLAN configurations. VLAN input takes 1 mutex per packet, so it decreases the number of forwarded packets by about 100,000 packets per second. While VLAN start takes 2 mutexes, which further decreases it by another 200,000 packets per second. So yeah, that's an interesting analysis of this routing performance regression, and it would be interesting to see how they can work past that. And it also brought up the obvious question in my mind is how much routing performance is hurt on FreeBSD by having VLAN interfaces. So I asked Olivier Cochard-Labbe, but he's never tested that. So he's added it to his to-do list. On my tests of a slower system, I had a Xeon 12 or 2630 versus this is a 2643. So mine is like 2 point something gigahertz instead of this one's 3.5 gigahertz. I get about 5 million packets a second through FreeBSD with no filtering or anything, just forwarding. But yeah, it'd be interesting to see what a VLAN does to that.
Yeah, what the impacts are in that one. And I see some nice papers coming up in conference talks to, how the performance was improved, or at least how people approach that problem.
Yes, like even just switching from FreeBSD 11 to 11 stable added like 1 million packets per second to my routing tests. Quite a bit of improvement going on in that area in FreeBSD as well. So it'll be interesting to find out what the ultimate culprit is and what the fix is on OpenBSD.
Okay, and our next story is another NetBSD story, which is about NetBSD, the first BSD introducing a modern process plugin framework in LLDB. So there's a blog post on blog.netbsd.org by Kamil Rytarowski. Close enough, I guess. A feature set, he writes, is a feature for debugging NetBSD applications without threads, has been merged with upstream LLDB. The number of passing tests this month has been increased from 267 of 12,035. So this is a plus 1,200, right? 10 times less, to a whopping 622. And this is a 135% increase within 1 month and approximately 50% of successfully passed tests in total. As usual, regular housekeeping of ptrace interfaces has been done on the NetBSD side. And during this month, he finished the needed native process plugin with breakpoints fully supported. In order to achieve this, he had to address some bugs and missing features and diligently debug the debugger, which is kind of a meta thing, sniffing on the GDB remote protocol line. And since NetBSD 8 is approaching, I have performed the also needed housekeeping on the base system distribution side.
Nice.
So that's something people might want to check out.
So yeah, they have the details of what's actually been done in NetBSD, including cleaning up the use of ptrace in the ATF tests, adding ptrace fork to all the non-x86 ports of NetBSD, adding the ptsyscall and ptsyscall emulated calls, and then they have details of what was done in NetBSD. It says by the end of March, all local patches for LLDB were merged upstream. This resulted in NetBSD being among the first operating systems to use a native process plugin framework with the debug server capability alongside Linux and Android. The current FreeBSD support in LLDB is dated and lagging behind and limited to local debugging. A majority of this work will bring FreeBSD on par. Would just be a case of search and replace NetBSD for FreeBSD. So hopefully that'll mean that FreeBSD can get caught up piggybacking on some of this work. And they have a long list of improvements here. They also have a demo where they wrote a little program called CrashMe. And you can see they have a simple bit here, and they compile it with GCC and run it. You get the memory fault. So they run LLDB through it, and it points, hey, here's the problem.
Okay. That's very precisely. Yep. Okay, nice. Yeah, and I think everyone who's LLDB consumer is benefiting from these changes.
So their next milestones that we'd like to support is adding watchpoint support floating point register support, enhance the core thing, and make it work for multiple threaded programs, introduce the PT set step and PT clear step into ptrace so that you can do single stepping, support threads in the NetBSD process plugin, and research the fgetpath flag for FCNTL. And then beyond, the next milestone is 32-bit x86 support.
Mhm.
And-
And they also mentioned that this work was sponsored by the NetBSD Foundation. Okay, very nice.
So yes, that's interesting new work, and looking forward to seeing that come to FreeBSD as well.
Or other BSDs in general that are using LLDB.
Yeah. So next up, we have the release of LibreSSL 2.5.2, which I guess coincides with the release of OpenBSD.
So that one brings in a couple of new things or changes they list here on the ftp-openbsd.org
Yep.
in the release
They
notes.
brought in the new realloc array function from OpenBSD for the memory allocators, and converted various places in the library that use it, such as CVB and buffmemgrow and realloc array. They say realloc array is similar to recalloc array is the new thing. It's similar to realloc array, but it zeroes out the memory first.
C for clear. Yeah.
Memory that becomes unallocated while shrinking or moving existing allocations is explicitly discarded by unmapping or cleared by writing zeros to it. So, in addition to clearing the memory before you get to use it, it means if you reallocate the pointer and make it smaller, it zeroes out the data that was possibly sensitive in it that's getting removed, which can be quite useful. They also added some new root CAs to their list, including the Security Communication of Japan and the SECOM Trust Systems. Added EVP interface for the MD5 and SHA-1 hashes. Fixed the DTLS client feature when the server sends a certificate request. Corrected handling of padding when upgrading an SSL-v2 challenge into an SSL-v3 or TLS connection. Allow protocols and ciphers to be set on a TLS config object in libTLS, and improved Netcat's TLS handshake CPU usage and server-side error reporting.
Okay, that sounds nice. And the LibreSSL project continues improvement of the codebase to reflect modern, safe programming practices. We welcome feedback and improvements from the broader community. Thanks to all the contributors who helped make this release possible.
And cut. Okay, just got to open up these
Phew.
emails and stuff.
I also have a couple of.
So we have Hardened BSD news.
That should be easy to do. 2 Knoxbox things.
Okay, so did somebody check that this article isn't April Fool's joke? It's because of the date on it. I don't know. It looks legit enough.
Oh. You mean, I didn't check that, but
Okay, Sean, if you're listening, your automatic changelog generation is pretty good, except for every change committed by Olivier is just, Oliver is just merge branch FreeBSD /11 stable master into hardened BSD 11 stable master. You might want to elide the automatic merge commits from your changelog, because they
it screws
just
up.
it's just a giant stream of meaningless commits.
Yeah, no details, but yeah, you're getting there.
Yep.
What else?
Okay.
Okay.
I didn't think so, but I thought I'd better check when I saw you guys do a
Yeah.
release on April 30th in the night time. So okay. Well, the automatic change log is quite useful. It's just, yeah, you might want to just regex out the automatic get ones that don't mean anything. Just for readability. Okay. Holy, look at the time. Okay. Ready for Tarsnap and
Don't
stuff?
ask me what time is it. Well.
Ready?
How do we do the questions?
So we do Tarsnap, then we answer the feedback thing, and then we'll just do the questions. I don't know.
In the Beastie Bits?
Yeah. So we'll do the Beastie Bits, and then questions. I'll take the first one, and you take the second one, basically, back and forth.
Okay. Yeah. All right.
Ready?
Mhm.
And remember, recording. The feedback segment is brought to you by Tarsnap. Backups for the truly paranoid.
Yeah, so if you're really paranoid about storing stuff in the cloud, then you might as well check out Tarsnap, your provider of the nicest and very well encrypted storage that you could have on the cloud or in the evil internet.
Yes. So you have data on your hard drive and you want to back it up. You run Tarsnap. It reads the files. Then it segments those files up and deduplicates them with stuff you've already backed up, so that you don't have to send data you've already backed up to the internet. And then from that, it generates a list of unique blocks, the data that you haven't backed up yet. It then compresses that data, making it smaller. It then encrypts and signs that data with your private key that only exists on your machine and anywhere you've copied it. And then that encrypted and signed block is then sent and stored online. And you only pay for the bandwidth to send that encrypted block and to store that deduplicated data. So you can do your daily incremental backups, and you don't pay for backing up data you've already backed up. So
Right.
it saves you money that way. And now, when you want to get it back, you can pull it back down, but the data is just gibberish until you decrypt it with the key that never left your computer.
Right.
But
And the whole
remember,
process is explained.
that's the only
website.
key. So you want to make sure that you have a backup of that key, because otherwise, if you're
No one
if the
can
only
retrieve
copy
the
of the
data
key is on your
anymore.
computer and your computer crashes and you go to restore your backups and you're like, oh, I don't have the key. Well, Colin can't do anything for you. Tarsnap is secure, and that means never, ever, ever can anyone get your data back. So yeah, make sure you print out that key and store it somewhere safe so that you can recover it when your computer eats the data rather than if.
Right. And there are regular, code checks about the Tarsnap code, so that people can rest assured that everything that might be a bug is being fixed or has been, checked out by crypto people that know a lot more stuff about, making things secure and keeping everything together without any security holes in there. And Colin Percival, who runs the Tarsnap service, is providing a bug bounty for people who want to get into that and find some bugs. And he offers money for things that people find and the stuff that he can fix. That's how he ensures that his source code is the best around with the encryption side.
Okay, moving into the Beastie Bits. First bit of news we has is latest stable release of Hardened BSD. 11 stable version 46.16. How did you guys get to 46 already?
Yeah, they're quite fast here.
So if you use Hardened BSD or want to, check out and get that latest version, which came out on last week. So next up, we have Knoxbug is looking for OpenBSD people in the Knoxville, Tennessee area. The leader of Knoxbug, which is the Knoxville, Tennessee BSD user group, has been going strong since 2016, and so far I've been very lucky to have people from IX Systems, including TrueOS, PCBSD, FreeNAS, FreeBSD, etc., attend and give talks. While this is great, we'd really like to have more representation of the other BSDs. So if you work on OpenBSD, NetBSD, or Dragonfly, or just anything else related, we'd love to have you at Knoxbug. If some OpenBSD people in the area would like to come out and speak or just attend, that'd be great. Please get in touch with them.
Mm-hmm. And the next one is also from Knoxbug.
Yeah, so they're announcing
basically
their next
meetup.
Yeah, the next meetup will be Tuesday, April 18th, so next week at 6 p.m. And they'll have speaker Caleb Cooper talking about advanced shell scripting. And it's at the Blount County Public Library, and the address and a Google map are there on the page. If you go to knoxbug.org. So hopefully a bunch of people will go out there on Tuesday at 6 p.m. And we look forward to hearing how the meeting went.
Are these recorded so people can watch them later?
I don't think so currently. That takes quite a bit of setup, but hopefully one day.
Okay. All right, and the next one is a short report from the E2K17 Nano Hackathon report from Bob Beck. So he basically put a bunch of, I think, up to 5 in total OpenBSD developers in his basement and had a little nano hackathon there to do some work that was, done on RelayD a little bit, and also a little bit about, OpenSSL work. So it's a small hackathon, but I think they got some stuff done in there. And he wrote a nice little article about what was done there and how it all went.
Yep, there's a bunch of references to hockey and interesting things happening. But they worked on a bunch of stuff, including nefarious syscall unlocking plans and libTLS and OpenSSL API changes and lots of other stuff.
Mm-hmm. And there's also some cooking involved, so I guess everyone was quite happy that they not only just hacked, but also had enough food and drinks there to survive the hackathon.
Yep. And apparently, I've been on every other podcast there is in the last 2 weeks. But I helped co-host the Linux Action Show last week because the other host was on a road trip. So I managed to put in action my nasty plan. And now Noah Chalaya, who's the host of the Linux Action Show, you can see linked directly in the video here, calls Linux a bad science project and switches to TrueOS.
Okay. Well, I call that a success.
Yes.
And they never invited you back? Is that
this was recorded April 1st. It's only the 12th.
Ah, okay. Yeah, okay. We'll see how this goes.
Yes, we'll have to see what they say in a couple of weeks. So now we have our first question is from James. He says, "Hi chaps, thanks for producing such a great show. My laptop uses ZFS as its root file system, and I replicate this to a FreeBSD home server for backups. I tripped myself up when I first started doing this because I rebooted the server and it tried to mount the laptop root dataset as / over top of the servers. In the end, I fixed this by setting the can mount property to off for the replicated datasets. But is this the right way to solve the problem? Presumably, you could also set the mount point property to none, and then that would also change it. Is there any reason to prefer one way over the other, or is it something else that I could be doing? So I think setting cam mount to none setting cam mount to off or to no auto, which is different, is preferable to mangling the mount point, because if you decide you want to mount, say, your laptop under, /laptop/stuff,
Backup.
mount points are inherited by the children. So if you set the mount point to none, then it messes up everything underneath it. Whereas if you just set cam mount to no auto, then you can still inherit properly. The tricky one is we generally set the mount points for a couple of the data sets explicitly, and that's what kind of messes it up a little bit. Having the USR data set be /USR rather than inheriting from the root. There are certain ways you can structure the pool to get around that, but it's a little more difficult. So there's that. The advantage to setting cam mount to no auto is you can still manually mount it, right? You can do mount -type or -t ZFS, the data set name, a directory, and mount it there. Whereas cam mount off will not allow you to mount it at all, which, depending on what you want to do, maybe is better, but possibly is not. So can mount to off or no auto is probably a much better bet than setting mount point to none.
Okay. And the next question comes from Kevin. He says, "Hi, I have a server that currently runs on Fedora Linux and has been running for years, and it would like to clean it up a little bit." So he also writes, "I'm running most of the services on virtual guests. I use QEMU and KVM virtualization to this, but I was thinking about switching over from Fedora to FreeBSD. I didn't find QEMU KVM port on FreeBSD, but I do know that FreeBSD has a Beehive hypervisor that Alan talks a lot about." Yes, he does, but not only Alan. And how good is that, he asks. "Does it have good tools to manage virtual guests like KVM and has some command or interface to manage networking? And can I use existing QCOW2 format disk images for guest machines, or do I have to convert them to raw format images or something? Sorry if this message got a little bit messy. Can you please let me know about your opinions and maybe let me know where I can find good documentation and guides about Beehive if I should switch over to FreeBSD?"
Yep. So Beehive is pretty good. The tools for managing virtual guests aren't quite as polished as the KVM ones, especially stuff for managing the network. It doesn't support the QCOW2 format. You'd have to convert it to raw. But FreeBSD also has Zen. If you're using Zen virtualization, then it does have all the tools and scripts and stuff, and they're all very nice, and it has all the network management stuff, suspend and resume, and live migration. It can use QCOW2 images and all that stuff. So because you're coming from KVM, Zen is probably a better approach than Beehive, although Beehive works if you want a very light and secure hypervisor. Zen is a more featureful one if you need more of those features.
Right. And if you want to read up a little bit more about QEMU, I could recommend the ZFS, or not the ZFS, the FreeBSD man page, or even the FreeBSD handbook page about Beehive. So we have a virtualization section there, and there's quite a bit of reading you can do on Beehive, how to set it up for different, systems you want to have in there, and some tips and tricks that you can also employ.
Yep. Do we have a handbook chapter on Zen?
I'm actually trying to write one currently, and it's coming. I got some, roadblocks there, but I'm trying to basically convert the Zen instructions from the FreeBSD wiki. If you go freebsd.org wiki.freebsd.org and then /Zen, there are the most recent instructions that are supposed to work.
And then for the actual Zen management stuff, it's all the same as Zen on Linux or anywhere else.
Yeah, that.
The guides you find online will work for that part. It's just the couple of FreeBSD specific bits, and there's the wiki page, and hopefully Benedict will finish the chapter on it soon, and it'll be in the handbook as well.
Yeah, it's in the works.
Cool. Next up, Ben writes about jails. It says, "Hello, Alan and Benedict. Today I started looking at the jails chapter of the FreeBSD handbook. While I've used jails for a few years, I've always created and managed them using IOCage or some script like that. I thought it'd be interesting to learn a little bit about doing it manually. reading section 14.3, creating and controlling jails, the handbook starts with the following. Some administrators divide jails into the following types: a complete jail, which resembles a full FreeBSD system; the service jail, dedicated to one application or service, possibly running with privileges, and so on. The handbook then goes on to talk about creating complete jails using either pre-built binaries or building from source, but only mentions service jails again when it talks about starting the jail. Is a service jail special in that it only contains the binaries and libraries of the service running in it? Or possibly does this have key different directory symlinked or nullfs mounted from the host into the jail? If a service jail has a complete base userland in them, I'm struggling to understand how they're different from a complete jail. So yes, a service jail would have only the absolute minimum bits that you would want, that you would need in the jail. The guide doesn't cover, or the handbook doesn't cover how to do that, because that's a lot more work and not that much of a win. Disk space is a lot cheaper now, and we have compression. Then you have the third type it didn't really talk about are basically what we call base jails or shared base jails. And the idea there is all the read-only stuff like, bin, user bin, that all the binaries that don't change are nullfs read-only mounted into all of the jails from one common set, so that you don't have to have 8 copies of the operating system in order to have 8 jails. With compression and lots of disk space, 8 copies can be easier, but when you go to do an upgrade, it can be nice to just do the upgrade once and restart the jails, and they're all running the new version instead of having to upgrade them each individually. But that one's up to you. But yeah, service jails are not covered because they're more complicated, and the instructions will be different for every service. And getting into the nitty gritty of how to decide which libraries you actually need and which ones you don't is a bit beyond the scope of the handbook.
Yeah. If you would describe all these jail management frameworks, that would totally blow up the whole handbook section. But it's a start for people to, get a basic jail running, and also, find other management frameworks that are out there that people can use.
Next question.
Okay. So the next question is connecting to episode 187, I guess, where we had one submission about a Windows shop that was trying to move to a little bit more BSD land. And this one is basically starting with a comment about that one, and also has another question itself. So he writes, "Hi guys, oh seriously? He's continuing to run services on Windows because the consultant who is paid for maintaining them said so? Poor guy. But you totally forgot the story about Delphix running MS SQL and ZFS-backed VMs with faster I/O than possible on bare metal because of CFS compression." Yes, we forget that, and it's a cool story, and showing the power of ZFS compression in a very business type way, because a lot of people are running MS SQL and are probably interested in these performance improvements. So Noel, or not, could just start by replacing the existing VMware installation storage with something like ZFS based, add some SSDs for L2ARC and ZIL. And wasn't there something about passing an iSCSI volume directly into a VM to improve the I/O latency? Also possible with ZFS, and yes, even Windows can boot from iSCSI. Yeah, so that's a good addition to what we mentioned already. And now his own question is, as you were asking for questions, anyone tips on migrating Linux servers userland into FreeBSD jails? Would be a great way to be able to gradually migrate services and still getting rid of legacy Linux machines. Tighter control and restrictions from VMs, better visibility, ZFS, etc., etc.
Yeah, so for that one, the FreeBSD Linux emulation only goes up to Linux kernel 2.6.32. So you can do that with CentOS 6, but nothing newer.
Unfortunately.
Yeah, otherwise, there'll be syscalls that aren't existing in the FreeBSD emulation layer. And there's work to move that forward, but it's not very fast. But yes, if you have CentOS 6 machines, you can just copy all the files into a directory and make a jail out of that directory, and CentOS will run happily on FreeBSD in a jail. But if the Linux is newer than kernel 2.6.32, and it will probably not work so well.
Yeah, That's the current limitation there.
And lastly, we have a question from our producer, JT. He says, "Hello, Alan, Benedict, and myself. Great show, guys. I have a question for those people out in the community. Now that the newer Xeon Phi X200 machines have come out and actually boot FreeBSD 11, video proof can be found here, and he has a link. Does anyone know if the older generation Phi cards, which were PCI cards that provided extra processing power as an add-on device, if those work with FreeBSD?" So he links to the Intel ARC page about that. He says the current X200s can be found here, but he's basically has the option of getting some used X100 machines from a place that's going to recycle them. And he wants to know if he can actually use them in FreeBSD.
Yeah, and if you know about this or have those machines running yourself, then send us a little link or a tweet. Well, the link would go to feedback@bsdnow.tv or tweet to BSDNow on Twitter. And actually, we were kind of happy that so many people answered our call for more submissions for questions and feedback. We got a lot of them, and we're still wading through it. So if your question hasn't been covered in this show yet, we'll have it in a future one. Don't worry. We're just trying to figure out which are the ones that need to be answered first and what the order was and where you sent them. So thanks for all the submissions up to now, and we'll have a couple more in future shows. We won't run out of questions and feedback anytime soon.
Well, thank you for watching, and we'll see you next week.
Yeah, thank you.
And cut. So we just need a cold open now. So you want to write something up for that? Quick?
Okay. So I have Summer of Code, YubiKey, the interview with level 1 techs. What else? Let me just skim through some of the stuff. That might be interesting. Yeah, maybe the Turtles on the Wire. Sounds good as a title. Yeah. So this would be more based networking implementation. Oh, Fuse, you mean? Yeah, good question. Whoop. Ah, okay. And you need that because you have an old Linux file system, or? Ah, okay. Why? Yeah. Yeah, do ZFS volume, and then on that volume you could do Btrfs, but not the other way around. Yeah. Whatever happens. That's the only use case I can find currently for that one. Da-da-da. Yeah, I need to do a little bit more with the Zen for the write-up. I mean, I wanted to use it on my own systems so I can know what I'm writing about and also provide some screenshots and stuff. But it blew right in my face this afternoon when I tried it. So need to do a little bit more
Well,
investigating.
yeah, it's
why
a bit
that
more
happened.
work because you kind of need it on a raw machine, not in a VM, right? Because it's a VM.
Yeah, I didn't use a VM. I did I used one of my cluster
Ah, okay.
machines, and so basically you added an additional bootloader, so it boots actually twice. So it boots the regular operating system, then
Well,
it
I
boots
think
the Zen specific
rather than a
.0.
different bootloader, you add a kernel module. You instead of loading the kernel, you load the Zen kernel, and the Zen kernel then loads the FreeBSD kernel, right?
Right, but this one got into a boot loop, so
Oh,
it didn't stop booting, and it was like, okay.
like
Then I tried
it's usually
updating
fairly
my base
straightforward.
system.
You just install the port and it works, right?
That's what I thought, but it didn't. So I have to
So
figure out whether I
it
just
it should
had
have added a
revision.
menu to the FreeBSD loader to choose not to do Zen, and you could have then got back raw FreeBSD and been able to boot and maybe fix it. But anyway,
Yeah, but that one didn't appear because menu item 7 is the that's the boot environment stuff actually.
yeah.
So they
Does it
probably
conflict? I thought we
are on top of
unconflicted
each
them.
other.
I don't know. Anyway,
I think so.
Anyway.
We'll investigate. So I do.
ready?
Yeah, I need one more item to whet
You
people's
only need
appetite
like
for the
15
episode.
seconds or so. It doesn't have to be long.
Yeah, it's. Should I mention the turtles on the wire, or is it more?
You can mention it. Just I would mention it as we talk about how a network card actually works, rather than Turtles on the Wire is kind of just a funny name, right? It doesn't tell people what it's about.
Yeah, that's true.
Ready?
Yeah. This week on the show, we're going to cover a lot of the different BSD projects, what they're doing in the open, in the Summer of Code space. Sorry, one more time. In the open Summer of Code space, yeah. This week on the show, we're going to cover Summer of Code on the different BSD projects, give you a little story about how to use the YubiKey, and also a nice interview with Wendell from the Level 1 Techs people, and also a very nice article about how a NIC works internally with the operating system. So stay tuned and keep with us because this is BSD now.
Okay. 3 hours later, that's an episode in the can.
Yeah.
Hopefully it won't take as long.
It was a lot
next
of
time.
content.
We'll get it trimmed down a little bit better in the future.
It's the question is, we have these nice long articles and we cover a lot because we want to get into the article and read a little bit about it. But this one, if we have 5 of these, then it stretches the episode. And also if you have an interview, that's I mean, I like the interviews.
Yes. I think most of the interviews are a little bit closer to 30 minutes than an hour like that, but
but it's not predictable up front how long.
And we don't want to cut people off. It's like, it's just, this is the best part. Just keep them talking.
Yeah.
We did the one interview with somebody from OpenBSD, I think, in Tokyo one year. The interview was 6 minutes. He had yes and no answers to all of our questions.
Yeah, but at least they were interviewed.
Yes,
I mean, they were brave enough to be interviewed in the first place. It's like, we have good people, but they don't want to be interviewed.
Yep. All right. It's dinner time here and probably bedtime there. So.
Yeah, that's the order of.
Is it 11 p.m. there?
It's 11, yeah.
Well, I didn't keep you up too late then.
That's fine. I was sleepy, actually, more sleepy before the show started,
Yep.
and now I'm too awake to get into bed.
Well, work on the Zen thing then.
Yeah, that might be I need to do some more tests, and I think I can do some of that tomorrow.
In the secret chat room, Roger is the Zen guy. You can always ping him if you get stuck.
Yeah, I will, because I also need a little bit more background information from Zen itself,
Yep.
and because he mentioned at Asia BSDCon that he's working on some stuff that might also be. I might as well add the newer stuff to the handbook while I'm on
Yep.
it, without mentioning the old stuff.
All right. I'll see you next week.
Yeah, cool. All right, thank you.
Bye.
Goodbye, everyone.
Into the string processing part. So I picked up a C standards library book to see what all I can do, what all I have in terms of library calls and whatnot. And I was reading that book on my way to work on the bus. And apparently, Peter Wem and Sean Bruno used to take the same bus for their work. And Sean saw me across the seat and reading this book, and